The show will begin soon. 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 The show will begin in 1 minute. The show will begin in 30 seconds. The show is beginning.
Computer vision, what people with vision impairments experience and want. Moderator, Abigail Stengel, NSF CRA Computing Innovation Fellow, University of Washington. First speaker, Stephanie Inyart, Chief Public Policy and Research Officer, American Foundation for the Blind. Speaker, Robin Christopherson, Head of Digital Inclusion, AbilityNet. Speaker, Daniel Kish, President, World Access for the Blind.
Okay, well, it's a great pleasure to have the three of you here today. Welcome to our VizWiz Grand Challenge workshop panel, where I have the pleasure of speaking with three special guests who will share about their vast experiences advocating for people who are blind or have visual impairments, and from their own experiences as people with visual impairments and who use and develop access technologies. My name is Abigail Stengel, and I am a CRA NSF Computing Innovation Fellow. My work is at the intersection of human-computer interaction, non-visual accessibility, and data privacy and ownership, and I work at the University of Washington. So a key goal of the VizWiz Grand Challenge is to cultivate conversations between people with visual impairments and the computer vision community so that research, products, services that make use of machine learning are developed in an inclusive manner and are reflective of blind people's leadership and the community's interests. So our three speakers have graciously agreed to help us cultivate this conversation. Thank you in advance to each of you. Before we dive in, I want to share a bit more about each of our guests and why we are fortunate to have you all here. So first, we have Stephanie Enyart, the Chief Public Policy and Research Officer at the American Foundation for the Blind. Stephanie serves as a strategic leader in developing policy that benefits people who are blind in education, employment, aging, and the intersectional issues of technology and transportation. I remember first learning of Stephanie through your work as a graduate student when you filed and won a lawsuit that now ensures that testing entities are required to provide accommodations that ensure that exams measure a test taker's ability rather than the impact of the test taker's disability. Thank you so much for that work. We also have with us Robin Christopherson, who is the head of digital inclusion at AbilityNet. Robin has been a prolific advocate for the power of digital technology in transforming people's lives. His work has led to accessibility improvements in business, government, universities, and many other organizations. Robin is not only an expert in accessibility auditing, but has served as an expert technical witness in the area of assistive technology and software, systems, and websites. And Robin has received numerous honors for his leadership in digital inclusion. Finally, we have Daniel Kish, the president of World Access for the Blind, who has long served as an advocate for the development of new technologies that support the independence of blind people. He's a world leader in perceptual navigation and echolocation, through which he has developed his own method of generating vocal clicks and using echoes to identify his surroundings and navigate. It really is an honor to be with each of you here today. And so without further ado, let's start with learning a bit more about your work in representing people with visual impairments. How about we start with Robin for this question? How did you get into your current line of work?
Thank you so much. Really good to be on. So I'm head of digital inclusion at a UK technology and disability charity, as you said there, AbilityNet. And I've been with AbilityNet for the last 26 years. I was one of the co-founders when it was spun off from a special needs product department of IBM. They realized that there was an awful lot more out there than just the products that they had. And so AbilityNet, we're a pan-disability organization. And that's really, really helpful because talking about intersectionality, there's an awful lot of implications of multiple disabilities and impairments. And, we're not all we don't just get the one disability. Certainly as we age, other things creep in if we don't get a rich mixture earlier on in life. So it's really important to have this multi disability or impairment approach. But yeah, I'm blind myself. I did engineering at Cambridge and soon realized that that wasn't going to be really realistic a career for me. So then I started to do maths as a teacher, secondary teacher. And I realized that you need to have eyes in the back of your head if you're a teacher in a secondary school. And when the ones in the front of your head don't work, then that was really challenging. So I very soon went to IT and, I've been in that field ever since, and have been lucky enough to be working with, as you mentioned, companies. We have a lot of services that we provide to companies. We advise government. I sit on various committees. They're called all-party parliamentary groups over here, where it tries to impact on policy and strategy, etc. So yeah, I've been embedded in the world of, I would say, the coalface world of disability for well over 2 decades. And just, it's like being paid to play, basically, with the latest technologies, including AI and machine learning and stuff like that, which hopefully we're going to touch upon a little bit today.
Wonderful. Thank you. Stephanie, how about you?
Sure. So I acquired a visual disability as a teenager, and I'm from a very rural part of California. So I quickly realized I needed to find a way to get out. And so education was the path for me. I couldn't get around my small town without the ability to drive. And so from that standpoint, I went to Stanford and thought I would be a literature professor, and I wanted to focus on disability studies. And then I quickly realized that from a systemic standpoint, people with disabilities weren't going to be as represented in a disability studies class to be my students if certain things weren't shifted in terms of the systems that create the reality that we live in. So I really became very passionate about doing systemic work in the cross-disability space. I spent time doing a lot of different kinds of organizing, political fundraising, coalition building. I went to law school. I launched organizations. I became a troublemaker, so to speak, good trouble. And I eventually wound up doing some policy advocacy work for some national disability organizations, and having deep roots in understanding how our issues play out in a cross or pan disability space is extremely helpful in the work that I do representing people who are blind and low vision. Because if we aren't able to really find that consensus and that touch point within the disability fold, within the cross disability space, we have a harder time in pressing on different aspects of policy change at that national, federal level. So I am very happy that I'm at AFB. I've been here for 4 years now, having spent probably about a dozen years in state and local government and about a decade in nonprofits. And so, long story short, I'm very passionate about doing digital inclusion work that I'm hoping will really be the next frontier in the disability civil rights movement.
Very exciting. Daniel, how about you? How did you get into your current line of work?
Well, we've got some heavy hitters here. I'm more or less totally blind from birth. I lost both eyes to retinoblastoma by the time I was a year old. I developed my own methods of getting around quite early. In fact, not long after I lost my second eye. So even in my earliest memories, I felt and or actually was freely mobile. Mobility is just one of those things that came very easy to me, and it was something that was expected fundamentally from my family. Little in the way of technologies back in those days. Even the white cane wasn't regularly taught to children with blindness. I'm 56 years old, so we're talking back in the 60s and early 70s. I did have a handheld braille compass from the age of 10, and I I used that compass. I always had that compass with me, and I used it to assist with orientation. So one might say that was sort of the earliest kind of piece of tech that I use. Moving forward a little bit, I was an early adopter of Braille note takers. So I was a user of one of the first, if not the first, portable standalone Braille note takers, the VersaBraille system from Telesensory Systems. That's going way back. But I've been a refreshable Braille display user ever since. And fast forwarding a bit, I ended up getting my master's in developmental psychology, but then realized that psychology wasn't exactly what I wanted to do. And in getting my master's, I had to do a thesis, and I, after several iterations and attempts, decided to do my thesis on the development of echolocation in blind children, which was not traditionally or routinely taught, and which most blind children didn't evidence a real level of proficiency. So I thought, well, I mean, it was sort of how I got around and how I was able to do the things I was able to do. So anyway, I developed a curriculum for teaching that as part of my master's thesis, and then decided to go into orientation and mobility and become certified. And it was only then when I realized that basically they weren't certifying blind people to do mobility. So I was the first totally blind person known to be certified as an orientation and mobility specialist. I experimented with mobility technologies very early on. I experimented with the MOAT, with the Polaron. I'm dating myself. Those are just old ultrasonic based systems. Fast forwarding a bit more, there was a real need, I felt, in the orientation and mobility field for more effective, more efficient, more impactful methods of training, teaching, methods of navigating, even instructional methodologies I took issue with. So that's kind of where I started World Access for the Blind, was to fill that gap, which I felt was considerable. I still feel it's considerable. So I have been working, World Access for the Blind has been working largely on a consultative basis with individuals. We've taught thousands by now of students, and I've moved into trying to get knowledge and know-how and learning processes in the hands of consumers directly, basically pulling the knowledge away from institutions, wresting the knowledge away from institutions, and putting it in the hands of consumers to guide their own learning development, particularly in the areas of mobility, where I feel we have quite failed that population, or in that area. So so I've been working a lot with virtual technologies, Soundscape, Seeing AI, some GPS apps, and developing a learning platform, a virtual self-guided DIY learning platform that's based quite heavily in binaural technologies. So binaural recording technologies, where you have a three-dimensional immersive capture of the auditory world. There's a video component as well, but the audio component is considerable in that I figured out how to externalize the frontal dimension. So basically, what is in front of you sounds like it's in front of you. So now that we've captured the frontal dimension through binaural recordings, we can design a wide range of auditory experiences that blind people can learn from, that gives blind people another option, another opportunity to learn from. So that kind of brings me into the technical space and where it meets navigation and mobility.
Wonderful, very interesting. Stephanie, I wanted to ask you, what technologies do you use to overcome accessibility barriers you encounter in your daily life? And what features do you find to be most useful and least useful?
All right. So I think for me, this has changed over time because I have a condition that has shifted and my vision has deteriorated over my teens, 20s, 30s, and 40s. And so from that standpoint, today I can say that I do use things like a closed circuit television or video magnifiers, mostly for identification purposes, meaning I can quickly identify something. I find this a little bit easier to use than actually other apps or services that are tailored towards giving me the same feedback loop. So it's not that I'm using them to really like read anything more than maybe one word. And so that's the use that I have for that type of technology. But in terms of computers, I would say it's really that blend between using screen reading and screen magnifying technology. I am more heavily reliant on the screen reading aspect of it. And I do use the screen magnification mostly so I can color reverse. I'm very light sensitive. And often other settings that would accomplish the same thing for screen magnification purposes, they do funky things to what you're trying to work with. And so when you're usually working with some sort of a program that's focused on screen magnification, it just has better options in terms of what you can do to change the amount of glare that I'm getting back from whatever screen type I'm in front of. To a more limited extent, I do use services like Ira, and that's usually to read something very brief. I would prefer, if I'm going to read something more extensively, to have kind of a digital version that I can use screen reading technology to digest. And also because of privacy concerns, which I think we might touch on later. And so from that standpoint, it's definitely this blend. I can only really speak for myself. Oh, I know I do use dictation software when completing certain tasks on my phone or an iPad, because it's much easier than being able to actually use the other functions to be able to type. And I'm not the kind of person that carries around a wireless keyboard that interfaces with this. So I do rely on dictation. And I am sad that dictation will often scramble things that I actually try to say more perfectly than it captures. In terms of really where the community is, I do want to tailor that my comments are purely my own experience, and every person who has a visual disability is really like their own unique version and composite in terms of like their training, their experience, their technology education, all of that, their access. I know that from our research at the American Foundation for the Blind that a very wide cross-section of people that are employed in the United States are heavy users of screen reading technology. Many more as well do use screen magnification technology, as well as a variety of note-taking devices, both Braille note takers, iPads, and other things like that to be able to capture notes while on the go. And those are some of the most prevalent technology-based accommodations in the American workplace, at least.
Wonderful. Thank you for that. Robin, I'm wondering if you have anything else to add in terms of the benefits or the features that you like to use.
Well, I'll totally agree with Stephanie that every blind person is completely different. I have no useful vision at all. I did when I was younger. So I went to a normal mainstream school. And so I have no Braille. I tried to pick it up a little bit later on, but I'm ashamed to say that I desperately need to brush up on my Braille because it's an extra string to your bow, and there's definite use cases for it. My go-to technology, myself personally, I should also say that AbilityNet, we're independent of any suppliers or providers of technology, but we need to be aware of all of them. So I feel like I'm abreast of the full range of technologies, certainly in the VI area, but, pan disability as well. So I feel like I'm kind of aware of what's out there. But what I've chosen personally is a Mac with VoiceOver. I have no useful vision, as I say, but I have to have a VM on it. I have to have VMware Fusion with Windows 10 still, and JAWS. And I'm probably 75% of the time in the Windows side of things, because you just cannot get the same sort of productivity going with particularly Office apps with the Mac and VoiceOver in my efforts, despite my efforts anyway. My iPhone, I would say, is at the center of my kind of love of technology. And we've mentioned, Seeing AI and Soundscape both happen to be Microsoft apps. I'm really heartened to hear that Daniel's working with Microsoft to kind of improve things in that area, particularly in the kind of binaural, immersive audio space. Huge fan of binaural audio. And I love the fact that the AirPods 3 support what's it called? Positional audio. Just like the Bose frames used to. So yeah, and as far as what Stephanie was saying about using, AI versus humans, I certainly do use Ira and Be My Eyes from time to time, usually when the AI has failed to come up with the goods. So I'm really looking forward to improvements in AI and machine learning. I would probably say the thing for me that is least useful, even though I was cited at one point, is anything video related. I mean, if it delivers the same quality of content in the narrative or in the audio description, then great. But I always get frustrated whenever I try to watch TV or movies, etc. I feel like the AD is just throwing us some crumbs, and you don't get nearly as good pictures as you do if you go for, say, the audiobook version. So I would always go audio first whenever possible. So yeah, that's me.
Thank you very much. Something that we've heard repeatedly from members of the computer vision community who have not interacted with people who are blind is surprise that people who are blind are able to take good pictures and videos to solicit visual assistance when using technologies like Be My Eyes, Ira, Seeing AI. And so I'll punt this to Daniel first. Could you share a bit about your journey in developing photography skills needed to use visual assistance technologies, as well as any ongoing photography challenges that you have?
Well, it's done my head in. First of all, I should say, going back to the idea that no one blind person can speak for any other, let alone all others. I have had a lot of experience with photography, not doing photography, but being around photographers. Not blowing my own horn at all, but I've been involved in so many media pieces, media segments, documentaries. If you do a Google search on me, you'll find out more about me than I myself know. And it just goes on for page after page after page after page. So literally hundreds and hundreds of video shoots. And I have managed to absorb what a lot of photographers do, what they're looking for, what they're not looking for, lighting, framing, angle, et cetera, et cetera. So I never cared that much. I mean, I'm glad that I can take a good photo of something, for someone else to review or for AI to review. I am a Seeing AI user. Traditionally, I've been pretty old school. Like, I was not a ready adapter of technology. Other than my, white cane and my compass, I was practically, navigationally tech-free until about 2018, maybe. I dabbled a little with Blind Square and a few of the other GPSs. But it wasn't until Soundscape came on the scene and Seeing AI that I really started using them more avidly. With Seeing AI, it's mostly short text. So I feel like I've become accustomed to interpreting AI poetry, I call it, getting an idea of what AI is trying to tell you. Soundscape, I'm a pretty regular user of it when I'm traveling in unfamiliar places, which is most of the time. I will say this. I do rely pretty heavily on the Apple image or scene analyzer when I'm taking video. So when I am setting up the camera, framing, angle, lighting, etc., I'll do it through the Apple camera first. And although the things it will say are a little bit random and a little bit arbitrary, it can give really useful information in terms of the scene that the camera is actually seeing. But what I really do to do the framing is I have it look at my face. It wants human faces. It grabs at human faces, craves human faces. So I can position my face at various points in the camera's view to get the framing right and the angle right. Um, uh, uh, I have used it to get information from the environment. So, for example, if I'm looking for a park bench, um, that can be quite a lengthy process. You have several acres of park and you're looking for a bench. But using the Apple camera, I can usually spot a bench. And then using echolocation, I can get myself to the bench, right? Because the camera is going to get you near the bench, but not even necessarily within cane's length of a bench. So if you're not able to image your surroundings at some distance, you're still likely to miss it. But the camera definitely will give you that kind of information if you know what to look for and how to angle the camera and so forth. So that's kind of I don't count myself as any kind of photographer. I'm not trying to make my mark as a blind photographer or videographer in any way, shape, or form. But I do it because I think that our learning platform needs a video component in order to be all-inclusive.
Very interesting. Yes. Stephanie, I'm wondering if you have other photography skills or strategies that you've developed when using assistive technologies or whatnot.
I mean, none of them are unique from what's already been discussed. I can think of features that I would love, and it's mostly because I have two young children, to know if everybody's eyes are open and everybody is smiling. That would be amazing to know if you captured that. And I don't think that, please let me know if anyone knows if there's features that actually give that level of detail, because I'll often use, as Daniel has described, use the existing features to be able to frame and all of that sort of thing. But I can't get that level of understanding as to whether or not I've captured something where I actually get all the faces, directly looking in the right way, potentially smiling and not frowning or sticking out their tongue, and eyes open. I mean, without layers of using technology. Yeah.
That's important for all of our photographs, I think.
One sledgehammer approach to that would be to just hold the shutter button down and do a burst of, 50 photos and then get somebody to choose one that's the most
I've definitely done that approach.
So when speaking about visual assistance technologies, for a few years now, computer vision researchers have been developing models for tackling two tasks of describing images. And one task is to create captions for images, and the second task is to answer questions about images. And Robin, I'm wondering, if you could talk about the usefulness of these two different types of approaches in practice. And in doing so, if you could comment on if one approach is preferable over another.
Sure. I mean, the main reason why people with very little or no vision are using a camera is to get information. It's not necessarily to take a masterpiece. So, what they need to know about is what we've been talking about, what's in shot. The lighting, ideally, the software would kind of compensate for as much as possible. But, once you've taken that photograph, or if it's a live image, in the short text channel of Seeing AI, for example, once you've kind of got that information, then, like you say, the two main things are knowing what's in the image, i.e. being able to tag objects, and also to gain meaning from that image, to interpret the kind of all the objects together and give you the context, or the kind of, is it trying to convey something? And that's often where you get a description all pulled together, where the machine learning or the AI component of Seeing AI, for example, tries to summarize that in a sentence, just pulling out, the key things that would give you a description of that image in a nutshell. I was talking to Saqib Sheikh a week before last, I think it was, about this challenge in Seeing AI. And I was saying, it'd be fantastic if you had the ability to get as much information as you can from the scene preview channel, which is, the scene channel, which is in preview. That's like beta, versus the one where you take a snap of just what's in the image, and it'll tell you, oh, it's a person or whatever. And they're basically two different API calls, and they haven't really got control over those. So the first one, you take an image and it looks at some objects in there. It throws away all the other information, and it comes back and it says, in this picture, I can see A, B, and C, some a pair of trainers, sneakers, a mug and a coffee table, that sort of thing. And the other one, which it uses for this scene preview, where you can then explore by touch the relative, the relationship between what's in the image. That's my favorite channel, by the way, being able to roam around. You can get the exact kind of edges of, if I took a picture in front of me here, I've got my monitor in front of me and I can, trace the exact extent of that monitor in that view. And that's a very different API. That's where you get a lot of information that is just available in that mode. So it's really hard to pull those two together. And I think that's one of the challenges that they're trying to address going forward. So as, in the same shot, you can get all of that information, plus you can get the context overview. And at the moment, those two are completely different processes. So, I think they're looking at bringing those together. So, yeah. We're also working with City University in London, trying to train a range of objects that are much more like the sort of things that a visually impaired person would be looking for, a braille display, a white cane, that sort of thing. But not only that, because some of those are in the standard models that, are available, that Seeing AI, for example, can take advantage of. But the way that they're captured for somebody who can't see what they're doing is often very, very different. So they wanted lots of blind people to take photographs of the devices that they use most commonly or want to find in a range of settings that are really quite inhospitable. So, on the sofa, half hidden under a cushion, or on the floor with the shadow of the table over it, making it really difficult to see. So, to be able to enhance or augment the machine learning models that these apps are using, the sort of standard ones, with ones that are much more kind of VI specific, I think is going to really improve the utility of these apps going forward. And I'm really excited about that as well.
Thank you for sharing that information about object recognition. Daniel, I was curious if you had insight into kind of when these systems that allow you to ask visual questions are the most useful in comparison to the captioning of objects.
Well, I work a lot in what I call the navigational space. So not so much, where is my note taker, but where is the picnic table? Where is the entrance to the shopping mall? Where is the push button, for a pedestrian crossing? That sort of thing. Where is the path? Where isn't the path? So I've often thought that a query format would be useful. It's obvious that cameras can recognize things like a park bench, like a monument, a body of water, a bus shelter. And if we can get AI to be smart enough to parse through those questions and actually match it with an answer, I see a lot of utility for that. Otherwise, you're just basically scrubbing through a lot of information, most of which is superfluous or not particularly useful.
Very helpful. Thank you. So shifting topics a little bit, I'm curious from each of you what your thoughts are about researchers or industry service providers collecting and using data to provide visual assistance in order to improve existing algorithms and developing new algorithms to provide visual assistance. Stephanie, maybe I'll start with you.
Sure. I have a lot of feelings about it, especially wearing, a legal hat. And from that standpoint, I feel like a lot of the predicaments that individuals are placed in that are considering whether or not to use a particular service for accomplishing a particular task is that we're really pitting the accessibility that people are striving for against privacy issues. And from that standpoint, I don't think that that's necessarily fair, and that there are some service providers that are asking for a legal right, like for example, a license to the content that they can capture within these sessions, when they don't necessarily need an actual legal license. They may need access to it for that time period, but it should be able to be noted that the content can be deleted in a particular time frame and that they don't have existing rights to it beyond a particular set amount of time. And so what I'm really speaking to is that my feelings are rooted in the fact that I don't think that people need to have that choice, as stark as it is, between being able to get that level of accessibility from a service and privacy. And so I'm really hopeful that services will hear that there is a need to better describe exactly what the purpose is for the kind of rights that they're requiring, that they will speak to the fact that data that is collected will be deleted and on a particular time frame, and that people have information very transparent and very easy to understand related to how, when, and why content that is captured in these sorts of sessions and contexts needs to be used, and for the types of purposes that it can be used for. And I hope that was responsive, but I'm not trying to call out anyone in particular, which is why I wasn't speaking in specifics.
Very much so. It's a very contemporary question and something that needs to be looked at. Robin, I'm curious if you have additional thoughts around the collection of data to provide visual assistance.
Well, certainly about data privacy more generally, I'm probably not the right person to ask because I do a daily podcast about the Echo, the Amazon Echo. So, but anyway, I think it's really, really important that Apple, for example, are going much more on device when it comes to processing of this information. And of course, the models that they use that hopefully have been trained to be better at recognizing, things that aren't totally in frame, poor lighting, all the things that we were talking about earlier, the objects that visually impaired people need to be able to find. Those can be done locally. The model, can be on the local device, and that machine learning, can leverage the power of the silicon on there. And that obviously has an impact or an import for privacy, for data privacy. Things don't have to be uploaded and crunched on, a server somewhere. And there's a huge broader context about bandwidth or access to the internet. There's many developing countries where it really does need to be on device. And there's a lot of visually impaired people in those countries for whom on device smarts would be absolutely essential for them. So, yeah, I think Google have had a lot to say in this space more recently as well, but I think on device is the way to go.
Mm-hmm, mm-hmm. Yeah, and thinking about how these companies can communicate to users how the data is being collected, processed, and stored and whatnot. Several ideas have been creating records of a data lineage. Essentially the decisions that are being made with the data and how. And I'm just curious if you guys have heard very much about the use of instruments that help support the communication of these practices and your perspectives about how that information can be more widely communicated to the community.
Although I
Daniel,
don't,
maybe I'll shoot that one to you, or Stephanie.
I don't know
ahead,
exactly
Stephanie.
how everybody in the community feels, but I think that there is probably a pretty large information gap between what people really know and what people also understand in terms of, what this data is doing, or who has access to it for what purposes and for how long, and et cetera. And so I think that there is a huge information gap to kind of conquer in this space. And I think that people would probably feel differently if they had more knowledge and potentially transparency in that space.
Very helpful. Daniel, what are your thoughts around data collection and data communication, data handling communication?
terms of the broad picture, I know for myself that privacy is important, particularly personal privacy. So I'm not an avid Be My Eyes or iRate user. And the main reason for that is maybe just my own proclivities, and maybe it's partly an age thing as well. I just am uncomfortable with a perfect stranger looking at my face, not only looking at my space, but potentially looking at faces. Because I may or may not know exactly where that camera is pointing or what that camera is seeing exactly. But when it comes to my own personal space, yeah, which is an odd thing to say considering how public I am about a lot of things. Everyone's seen my home. So I'm not sure what the issue is, but there is an issue with me. So, and I remember being interviewed by Be My Eyes at one point. They called me, no idea why, to participate in a survey about their services. I told them up front that I wasn't really a user of their services. They wanted my input anyway. And according to the interviewer, he was really surprised because I was the first person to raise that particular issue. I was the first person that he'd surveyed to raise the issue of privacy. So, be that as it may, that's one of the main issues I have personally when it comes to using those services. Now, professionally, I'm up for anything that liberates people. I'm up for anything that facilitates the execution of responsible personal freedom.
That's very important. And I'm thinking with these visual assistant technologies, we're talking about the use of AI and possibly the data collection to enhance the AI. I'm curious, what level of interaction do you want from a visual assistant technology that interprets the visual information? And, do you prefer that the interaction comes from humans or computers? And I'll stay with you, Danielle, for that question.
Is that to me?
Yes.
I'm sorry, the audio is skipping for some reason. I don't know why. I definitely prefer interacting with AI, but then I'm a diehard introvert who's also on the spectrum, so I don't know that I'm very representative in that regard. But privacy is one of those reasons. I guess I feel like AI is just going to dispassionately provide whatever information it knows, whatever information it can, and it doesn't really care what it's looking at, what the context. Whereas humans undoubtedly and unquestionably do. And so interacting with a human is just a very different experience. I'm not saying it should be eliminated. It's just not an experience that I personally.
That makes a lot of sense. Stephanie, I'm curious what your preference is in terms of using humans or AI to receive visual assistance.
I mean, I do think I am somewhat old school from the standpoint that I would always prefer a human over technology when I'm trying to get questions answered, because I feel like a human is going to understand and field the question differently than anything that is in a created space. But I think that there's a dichotomy. There's different kinds of tasks that I have that are visual, that are fixed through this technology. So if this is purely for enjoyment, I want, let's say, a piece of my children's art described vividly to me. I am comfortable with that being, a created computer space, because I don't feel like there's anything that I would need to ask as follow-up. It's purely for enjoyment. Whereas if I'm trying to make a decision about something and I may have some direct follow-up questions, I'm not always, certain that I'm going to be able to get exactly what I need in the fastest way possible in a time crunch situation from computers.
Robin, what's your perspective about the use of humans versus AI for image description and visual assistance?
I would definitely agree with Stephanie that it's a case by case. It's a use case thing. So when it comes to scanning a document or taking a paper document that you want to deal with later on, then a quick snap with your camera. The OCR side of AI is startlingly good these days. So it really depends on what, leaning to the strengths of the AI. So that sort of thing is great. Product recognition, like grabbing barcodes, it's still really, hit and miss. So unless we had one of those kind of industrial strength barcode scanners, which I think use infrared instead. So maybe there would be a plugin for, like an add-on for an iDevice, for example, that would make a better job of that. But yeah, so when it comes to sort of object recognition or interpretation of visual stuff, I would go human any day of the week. When I'm out and about, I wouldn't choose either AI or human. I would choose a dog. And that is absolutely fantastic. I really can't imagine a time. I can't foresee a time. I could imagine one, but I can't foresee a time in the near future when AI plus haptics plus any kind of robotic intervention would have the same level of, potential hazard avoidance and just seamless. I mean, I shouldn't do this, but I always switch off because it's just so effortless. And I'm at my destination and I wasn't even aware of the kind of road crossings and stuff in between. So it's kind of that level of ease when it comes to a guide dog. So yeah, I'd love there to be a case in the future when AI is best for all of these, because not everyone has access to a guide dog or a human, etc. But yeah, we're not there yet.
Great. So we're coming to an end, and while we've touched on these topics kind of throughout this conversation, I'm curious from your perspectives, what are the most important open accessibility obstacles today that should be solved first? And I just want to note that we will have computer vision researchers in the audience, and so one may be inspired to even pursue your ideas. So, if you can share about your individual perspectives as well as any other ideas that you hear from the broader community, with the understanding that everybody has a unique preference. Maybe Daniel, we'll start with you on this question.
Again, not wanting to speak for everyone, but if I were to collapse the experiences I've had, my own personal experiences, I've been to over 40 countries, and I've worked with over 3,000 students of every imaginable age and background. I guess I would say it's interesting because even avid travelers, good travelers who've had a lot of experience and a lot of proficiency, sometimes there's just maybe one thing that they struggle with in terms of mobility or navigating. And that one thing can prevent the trip. It can prevent learning a particular route. It can prevent learning to get to a particular place. And it's different for different people. For many, it's road crossings. We managed to put the fear of God into blind people when it comes to road crossings. For many, crossing over open space and able to target your destination accurately and efficiently. For some, it's mediating interaction. So where is the person I'm looking for, kind of thing. For many, it's recreation and leisure. Especially in some countries, some more than others, we've marginalized or isolated or excluded blind people right out of peer-based recreation and leisure. So that's moving quickly, moving through complex spaces, being able to avoid or interact with environmental features. So I guess I'm kind of in a way saying everything, but it boils down to interacting with specific elements or features in complex spaces, crossing open space, and dealing with vehicular traffic, the social environment, and then, of course, seamless access to the symbolic environment, so public signage, labels, and markups.
Robin, what are the most important open accessibility challenges today that you think should be solved first?
I can't believe I'm going to say this because a large part of what AbilityNet does day to day is advocating for digital accessibility and helping organizations to make their websites and mobile apps more inclusive. But it is a long journey, and it's going to carry on being a long journey. And whilst we also spend a lot of time telling companies that these accessibility plugins, I'm not going to name any names, but you know who you are, that purport to be the silver bullet, aren't, and in some cases can actually degrade the accessibility of a website, particularly for a screen reader user. There's still going to be this gaping gap in accessibility because, you know, companies are slow to adopt. They find it daunting, or they're, you know, SMBs, and they haven't got the kind of bandwidth to do that. So there is a large area where AI can be better applied to patching accessibility. That's a terrible thing to say, but, you know, I feel like we need to go there. Where does vision, you know, related AI come in? Well, the page that you're looking at gets a lot of context from the overall visual structure of it, the layout, the relationship of one page element to another. You know, think of all the effort that goes into user testing and heat maps and stuff like that. There are nuances there that you just don't get as a blind person when the page is linearized, regardless of how much semantic information is there with headings, etc. But so I feel like there is an overlap there. It's certainly a domain where AI can have a better impact, and at the very least not actually degrade the experience when a plugin is added to a site, hopefully improve it. But also I think there's a lot of the visual aspects of a web page or the UI of a mobile app that could be better machine understood, and somehow that could be layered onto the experience of blind users, for example, who don't get any of the visuals of what they're looking at. So yeah, for me, I would say I was a power user when it comes to technology. I still find the internet a really frustrating place. I don't know about you guys. And I just want that to go away as quickly as possible, please.
Thank you. I hear you. And Stephanie, how about for you? What are the most important open accessibility obstacles today that should be solved first? And I'm also curious, in your perspective, what are the most effective advocacy efforts to move these ideas forward?
I mean, I think that for a dynamic issue like the issues that we've been touching on in this time together, there's really like a whole set of tools in the toolbox. And, you know, there's very important tactics and strategies involved in everything from corporate advocacy to user feedback to education to litigation to policymaking. All of these are important role makers and tools in chipping away at different aspects of this. One kind of example that I could give is the United States has the Captioning and Video Accessibility Act, which has been around for a while. And, you know, in terms of like the user uploaded feedback, user uploaded content, it's an interesting landscape because, you know, it's something that you could certainly, you could attack it from a couple of different angles in terms of as a problem. The CVAA, the Captioning Video Accessibility Act, it really, for many corporate players, it was seen as like a call to action as to what they should do to be able to create this more accessible video programming content. And others really saw this as kind of, you know, a way or a mechanism to consider and, you know, provide kind of that lowest rung of accessibility. And so at this point, you know, there is something that could be done, and looking at the CVAA and looking at where it could go from here as kind of a piece of legislation, we're kind of at the spot of, you know, refreshing it and looking at it as needing another iteration to be able to better spell out some of the intricacies of how to tackle problems. And so I give that as like an example of, you know, there's a problem that could be kind of, you know, it could be legislated, it could be, you know, you could look at it from, okay, that corporate advocacy angle might just solve everything, and it will to a certain extent. It's not going to bring everyone along. And so anytime we're at a spot to be able to make progress with digital inclusion, it's like you have to think about all of the different tools and what role each of them play in kind of crafting the solution.
Well, thanks to each of you for sharing your expertise. I feel like we've just barely touched the surface, and so hopefully this is the beginning of many more conversations. I'm sure this conversation is very helpful for our audience, and we look forward to the influence of your leadership and advocacy efforts, and we hope that you've enjoyed participating in this panel as well. And so with that, we'll say goodbye.
Next panel will begin shortly. 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 The show will begin in 1 minute. The show will begin in 30 seconds. The show is beginning.
Perspectives of industry developers on the challenges and opportunities for advancing visual interpretation technologies. Moderator, Samreen Anjum, PhD student, University of Colorado, Boulder. Speaker, Saqib Sheikh, Software Engineering Manager, Microsoft. Speaker, Will Bettler, Chief Experience Officer, Be My Eyes. Speaker, Karthik Kannan, Chief Technology Officer, Envision. Speaker, Ann Taylor, Principal Program Manager, Microsoft.
Hello everyone, welcome to the second panel of the VizWiz workshop. My name is Samreen Anjum and I'm a fourth-year PhD student at the University of Colorado, Boulder. I'm a woman with dark hair, wearing a printed top and a printed scarf today, sitting in my home office with a white plain background. It is my pleasure to introduce to you today 4 amazing experts from industry who are joining us today to share their experiences in building products and services that support people with visual impairments to learn about visual content. First, we have with us Saqib Sheikh, who is an engineer manager at Microsoft, where he co-founded Seeing AI, which is an app which enables someone who is visually impaired to hold up their phone and hear more about the text, people, and objects in their surroundings. This application has won multiple awards, and we're very excited to learn today about his experience in building such apps. We also have with us today Ann Taylor, who is the Principal and Program Manager at Microsoft, and she has also played a key role in the development of the Seeing AI app. Ann has an extensive accessibility advocacy experience and has been helping engineers at Microsoft understand the end user's perspective when building products and services for several years now. Next, we have with us Will Bettler, who is the Chief Experience Officer at Be My Eyes, a free app with one of the largest online communities that supports visually impaired individuals to get free on-demand live video support from around 4 million volunteers and companies. These remote visual assistants help them interpret their visual surroundings and overcome accessibility barriers. Will has also written numerous motivational articles about his journey with vision impairment and hosted 2 podcasts on the topic of vision loss and accessibility. Finally, we have with us Karthik Kannan, who is the co-founder and chief technology officer of Envision, a company that provides technology to help people with visual impairments in their daily life. The company builds an app and smart glasses which help people learn about their surroundings, including to read text and recognize faces. Thank you to all 3 of you for taking the time to share your expertise with us today. Before we start, I do have a request. To ensure the accessibility of this podcast, please remember to describe yourself and mention your name before you speak. So let's begin our conversation. The first question I have for you all today is about your role. Could you please share a bit about how you're trying to improve products and services for people with vision impairments within your company and how you got into your current line of work? And we can probably start with the order of introduction. So maybe we can start with Saqib, go with Ann, then Will, and then Karthik, and then switch up the order in the next question.
Great. Hi, I'm Saqib Sheikh, and I am a dark-skinned male wearing a black shirt in front of a plain background. So I work at Microsoft. I've worked here many years now on a variety of products, but as someone who is blind myself, I've always been interested in how do we use technology to improve people's lives for everyone and make it more inclusive. And then a number of years ago now, 2014, I had this opportunity at the company-wide hackathon to start working on a side project which turned into Seeing AI, looking at how do we take the cutting-edge AI technology from Microsoft and around the industry and bring that to improve the lives of people with visual impairment. And so I now lead the team, and we have the Seeing AI app on iPhone, and as you heard in the introduction, we sometimes describe it as a talking camera, which you hold it up and it'll recognize people, read text, and describe people around you, but then also works the photos from other apps or already on your phone. So that's kind of what the app does, but I think the bigger philosophy is really this of, I see our team as this ongoing conversation between the visually impaired community on the one side and all the scientists at Microsoft working on the cutting edge on the other side, and just always looking at how do we bring the latest technology to bear on our users' problems. So yeah, that's a bit about me and what we do.
Thank you, Sakib. This is Ann Taylor. I'm an Asian woman wearing Microsoft shirt, and I'm actually sitting in my living room here at home. So how I came into this role is I've been an advocate for equal opportunity and accessibility for the blind for a very long time. Before I joined Microsoft, I was the Director of Access Technology at the National Federation of the Blind. And then have an opportunity to join Microsoft to advocate for accessibility on the inside. Things that I do from day to day are co-create products and services with engineering teams across Microsoft, give feedback on new and existing technology that Microsoft creates via testing, and comment on or provide feedback for usability design of different product areas. And I think another component that I do at Microsoft is to create a culture and awareness of accessibility. When you're looking at 100,000 people working together, there are a lot of community that we can entrench ourselves, we as in people with disability, to raise the consciousness of the company for accessibility, and so that accessibility will always be a core competency of the business. And this will help Microsoft, in fact, live out our empowerment mission to help every individual to achieve more. So anything from technical feedback to usability feedback and create the right culture for accessibility to thrive. That's what I do here at Microsoft.
Thanks, Anne. This is Will, and I am a white man sitting in my office with a couple of posters on the wall in the background, and my role at Be My Eyes kind of has evolved from initially, my skill set is as a writer and a journalist and researcher and sort of marketing and communications. But what I do at Be My Eyes is kind of help to tell the stories of not just our blind users and those who, like me, have varying degrees of visual impairment around the world, to take those stories and bring them to our product team, to our technology team, to our board members or investors, and represent them really accurately, so that we're making really good decisions for the community and everything we do with the product. So it's a product role in that regard. But also I'm in this unique place where we have this group of millions of volunteers who are also having an experience with people who are blind or have low vision. And so we spend a lot of time also trying to figure out how do we incorporate these allies into our mission, and how do we leverage the data and insight and information that we're getting from these wonderful people who are of assistance, to also channel that into making better products, better experiences, and ultimately better quality of life for people who are blind or have low vision. So it's a little bit of a marketing role, it's a little bit of a branding role, and it's certainly product management as well. And we kind of sit on the fully on the human interpretation side of the spectrum. None of the visual information delivered in the app is automated or machine driven at this time.
Hey everyone, my name is Karthik Kanan. I'm from Envision. I'm a Indian person, brown skin and with a beard. I'm wearing currently a black and white striped hoodie, and I have a wood paneled background. I'm sitting in a room with a wood paneled background. My role at Envision is that of as a co-founder and a chief technology officer. A lot of my work is talking to users and understanding what they need in order to be able to access the visual information around them more easily, and also looking at what the state of the art in artificial intelligence can do reliably, and try to bridge and try to basically build products out of that. So we spend a lot of time talking to our users in the visually impaired community to try and understand what their needs are, and also looking at what the state of the art AI can do for those specific needs. So our product basically offers a lot of different, or tries to solve a lot of different types of visual challenges. So we build tools that help people read all kinds of documents or books, to being able to recognize their personal belongings, to be able to personalize the whole face recognition part of it. So we operate in a lot of areas of computer vision, and in each of these areas we try to bridge that by bridge it to the visually impaired community by talking to them and kind of giving them what they want, in terms of features within the Envision glasses or within the Envision app. So that's what we do.
Wonderful. Thank you so much. So my next question is about challenges. What are the challenges that are encountered in trying to improve upon the state of accessibility in practice? And if you can, please comment both on challenges your team has overcome as well as any unsolved problems currently encountered. And whoever is willing to go first, we can start, or we can probably follow the same order again.
I'll jump in real quick with respect to challenges. I think one of the difficult parts of developing technologies are the skill set of engineers that are graduating from colleges and university who's never been exposed to accessibility before. So accessibility, often a discipline where you learn on a job. And we are very fortunate as an industry to have really quick studies among engineers, and they can really learn everything well and quickly, and come up to speed very quickly, and be able to deliver with great precision. However, I think industry need to solve the challenges where accessibility need to be more entrenched in educational system, so that when it comes to working in IT professional or working in artificial intelligence, we already have accessibility as a core competency taken care of. I think we need to do more there at Microsoft, and I'm sure across the industry we are facing this problem. So it's up to people like me and Sakib and others who have disability to really integrate ourselves well with new engineers to ensure that they are up to speed with respect to accessibility development. And I've done that. I'm sure Sakib has done that. And this is a challenge that I think can easily be solved as an industry. several of companies working together to ensure that core competency and accessibility is taken care of in the educational early on.
I think I can
echo that.
Sure, go ahead, Sakib.
Sorry, yeah, this is Sakib. I would echo that. I can think of this as a blind guy, but also as an engineer, that when you think accessibility all up, the biggest challenge over the decades has been awareness. Whether it's websites, whether it's apps, the biggest challenge remains that most people don't know what they need to do to make accessible apps. I also have a couple of comments around seeing AI and our work here and the challenges we're solving, but maybe Kartik, I know you wanted to jump in with something, so maybe I'll come back to that.
Sure, Sakib. Hi, this is Kartik. So, I think an extension of that problem also is something that I see specifically in the computer vision space. The way I see it is we don't have, since accessibility is not really a core, is not, the awareness for accessibility amongst technical folks in general isn't there. There is, for example, a lack of data sets that, have data from the point of view of a visually impaired person, right? I know Microsoft has done some work in that area, but, I'm talking about a really nice, well-labeled data set that, researchers can readily access to and sort of test their own models against, that kind of a data, right? For example, when we wanted to build, a document or a layout detection AI on our side, right? We found a lot of images that were very neatly cropped or well taken, but someone who's visually impaired often always has, some issues with taking the image in the right angle. So we found that lack of representation in the data set, of images taken from the point of view of a visually impaired person very difficult, because, we know that our users who are using the glasses or using the app don't necessarily take a very well cropped or very well framed image at all times, right? And this is also seen in some areas, like, for example, object detection. Any object detection data set that you pick, right from ImageNet to Open Images, they all have images taken by sighted folks. And that, basically means that if you're trying to build AI and if you're trying to work at a company like Envision, trying to build AI and accessibility to together in a single product, the models themselves aren't accessible, right? The apps could be accessible themselves, but models are not accessible, like in quotes. So I think that lack of awareness spreads not just to people building products, but also building deep tech and computer vision as well. So that is something I would love to see change over the years, that we see mainstream data sets incorporate data from people with disabilities as well, so that when we want to build products or when researchers want to test their models come out of the gate as inclusive ones.
That's so true. If I could jump back in, you take the words from my mouth. Really, when it comes to the computer vision side and seeing AI, I think of this in two sides. What you were saying, Kartik. Sorry, this is Sakib. We're supposed to introduce ourselves. So if you think about the machine learning side, there is too often this idea that we're going to have a data set, we're going to train a model, and then from this data set will emerge this model that represents this data. But unless the data is inclusive and representative of your audience, and in our case, the audience is people who are blind, taking not well-framed photos necessarily, then your model is not going to be as good as it could be. And so we're definitely looking at how do we make more inclusive data sets. But a challenge with that is how do you maintain privacy? Because if you have too few users of any sort, then they might be too easy to identify them, or your challenges of how do people donate their data if you don't know what's in the image at the point that you take the photo. So there are a bunch of privacy issues with generating these inclusive data sets. So we're looking into that, but we're also looking into other approaches like personalization, where maybe you have a large general model, but then we can personalize to each individual, because each and every one of us is different. And that's another way that we're looking at getting over this lack of data in terms of machine learning algorithms. And a final point here is sort of blending machine learning algorithms with the user experience, because what we're creating here are new experiences that keep the human at the center. And traditional like computer vision, machine learning approaches might say, okay, have an image in, answer out. But really, this is all about how does the user move the phone? How do they hold the camera? What actions do they take? What were they intending to do? And these are all very human-centric actions. And how do you incorporate that into the machine learning process so that we have, this human-centered AI as well? So I could keep going on about this, but I'll hand it over.
Yeah, and I'll just chip in. I think like as the sort of from the like human only perspective, I think the there are two challenges. One is that we're really committed to the idea of Be My Eyes being free and being available globally, and so there's a lot of overhead that comes with that, and finding a business model that supports that is challenging. But we've had really great luck so far in terms of both a corporate business model where Microsoft was one of our first partners in that area, and also exploring individual ways that individuals can support and become members for additional experiences and value streams while maintaining a core free product. On the data side of things, we actually have quite a lot of ability to access inclusive data sets, but we encounter the same questions about ensuring privacy and really making sure that the data is treated ethically. So that's something that we kind of get into, we can get into later, but we're a little more careful about. And I think where we're unique is that we have a lot of challenges around like localization and internationalization, in that we have interactions happening in hundreds of languages, and so in some ways it's the most inclusive data set you could imagine. So we don't have the ability to necessarily like translate all of this, and whether you're talking about it from like a community moderation standpoint, or whether you were actually going to try to derive some data insight from that, it's a massive challenge that you can't just use volunteer labor for. So we kind of those are the kind of three areas where I think we where there's the most challenge, but also maybe the most opportunity.
I am with Will that we don't have enough participant from persons with disability because due to localization, due to the lack of exposure to technology, due to many things. And I think we need to do more to ensure that no matter where you are in the world, you have an equal opportunity to participate in something as important as help shape and form the type of data that we will get as an industry to further train and teach AI, so that we would ensure that the system is not biased. So it's something that we all as an industry need to help solve together.
Yeah.
Yep. And that is actually a good segue to my next question. So my next question is about humans versus artificial intelligence, the role of humans versus artificial intelligence in these systems. So we know that there are a spectrum of solutions for visual assistants that could range from sole reliance on remote-sighted humans to sole reliance on artificial intelligence. Could you talk a little bit about which solution you use or prefer? And could you also discuss what aspects you think should be done only by either humans or artificial intelligence?
I think this is Karthik from Envision. We strongly believe that we need to really manage expectations around what is AI good at today versus what is not. I think a lot of times, even from within the AI community, there is a lot of, I would say, an inflated sense of what the model can do or what the technology can do at this point. I think there are some very well-defined tasks. For example, I think OCR is a task. Optical character recognition is a task that AI has gotten consistently good at. It's definitely not there yet when it comes to reading text from pretty much any surface, but mostly we've seen it make remarkable strides in the area of document. If it's a document, then OCR works really well. So I think there are some areas where only AI solutions will work. And I think there are some solution areas, for example, when it comes to outdoor navigation, right? We constantly get asked by people in the community, is it possible to build a model that can help them recognize, traffic signs and things like that? Of course we can. Should we do it? Absolutely not. At least where I come from, where I look at it, I don't think we should be building such models just yet and putting it out there, because those are things that can definitely harm a human. If they don't end up, it has more potential for harm than good at this point, because the models, could have some bias in them, which could end up hurting a human. So those are areas where definitely not having a machine in the loop actually really helps. And it just needs to be with AI. I think it's a joint effort between the technologist and the user to understand what are the problems that are, and what are the problems that can be solved by AI and what are the problems that can't be solved by humans. And I think AI excels at well-defined tasks where the data looks more or less similar to what it's been trained on. So you don't have a lot of variance in the kind of data that you might see. But and it also needs to be in a setting that might not cause direct harm to a human being, whereas the machine should entirely be out of the loop in areas where we can see that the machine can indeed harm humans. There could be a point in time where we could use, maybe when smart glasses become more mainstream, we could have special sensors or hardware that might augment what the AI could do, like some kind of sensor fusion along with the model could make things almost as accurate as humans. It could end up becoming like the OCR level accuracy, but I think we're not there yet. So those are areas where we definitely will never move into. And I think we should probably just wait for things to progress before trying to jump into those areas.
I do have hope for AI, though, is that because there are things that I think with technology, the right level of technology, we can help solve. As an example, I really do believe that the age-old problem of blind persons accessing graphs and charts and derive at proper interpretation right now is still very much a combination of working with human and working with assistive technology to get at the right data. But I think AI can provide a way forward so that there's less analysis that has to be done and less exploration. I think AI can surface the relevant data quicker. I think that we need to work together so that blind people can get access to graphical type data type in a more meaningful way, in such a way that that we can have an equal opportunity to succeed in a timely manner compared to sighted persons. I think AI will help us get there. It's not there yet. It's amazing to me, though, that this type of problem has been with us for a while now, and we have not yet solved it. So I guess I'll put a challenge down here that where we all gather together, we should look at a way to bring new technology to help solve complexity of charts and graphs. I think it's really important for us to do this so that more blind kids can get into STEM easier.
This is Karthik here. I think one other area where currently we see a lot of human involvement, but hopefully in the future we could have AI take over with the right kind of inputs, is image captioning. I've been following image captioning a lot because it's one of those areas that are very, very interesting to us. I've, for example, I've seen the remarkable strides that cognitive services, Microsoft Cognitive Services, has actually made with the image captioning, AI over a period of time, and not just Microsoft. I've seen other companies make these kind of remarkable strides, and we've been following how the image captioning AIs in the very beginning used to be really, I would say, apart from being inaccurate, they would be very broad in the way they would describe things. I think now it's becoming a lot more specific as as the years go by. It's still, describing an image is still something that users of the Envision app or the glasses still do with the glasses, but then they always double check with the human as to what the image actually is, or they want to have more detail. And I think as the years go by, that is one really exciting area that I think can benefit a lot of people with visual impairment, is for AI to be able to generate good captions with some fair amount of detail, and can remove the human out of the loop. For example, when we get an image on WhatsApp, you could just have it interpreted by an image captioning AI versus trying to get your friend or a family member to describe that for you. So that's one more area I would add, along with mathematical equations and charts, as something that I think is going to definitely be cracked in the next few years.
Totally. And this is Sakib. Yeah, our team has even more work to improve image captioning coming out over the period to come. So excited by that. And math, charts, these are all really good points. Bigger picture, as someone who's blind, I think about this on different, it's a continuum. So I don't think just human-powered solutions or just AI-powered solutions are the answer. To me, I think about privacy, efficiency, accuracy, and independence. So someone is likely to maybe choose an automated solution when you want that efficiency or independence that just comes of getting whatever answer you can. It also gives you more privacy because you might not want to discuss your bank balance with a stranger. But then you go to the other extreme where you really want accuracy, or you want to ask about a difficult task. Maybe today that includes something with a lot of interaction, including navigation, but many others as well, like finding an outfit that's good for a particular social context or so forth. And so I think the cursor is going to move along that spectrum back and forth for different tasks over the years. And I think, AI is becoming way more capable than it was when we started seeing AI, but there's still so many things for which we rely on humans, either because it's more accurate or just more pleasant or convenient, but also be aware it's not always available or something you want to use. So
I couldn't agree more, Sakib. And I think, this is Will, from Be My Eyes perspective, it's tempting to say there's always going to be tasks that we need human eyesight for, and yet I don't think any of our volunteers would be upset if we sent them an email tomorrow saying we don't need your assistance anymore. We can do it all on our phones, right? And I think that just due to the event that we're at today, it's if you take some of these examples of things that I could throw out, all these examples of things we see on the app on a daily basis, whether it's something like Sakib saying, how does my outfit look, or identifying a strange dog in your backyard, or are the men at my door actually policemen? That was one we heard recently. So these things seem entirely human tasks where you really need a human eye, but it strikes me that it's not so much about the machine's ability to see as it is the kind of task targeting that happens in advance of the actual vision interaction. And So I don't think it's out of the question to think that we could knock some of these really, kind of difficult seeming computer vision tasks off the list and hand them over to the machines from humans. But it just goes back to that data set and also maybe some really creative minds thinking about how are we targeting tasks, and maybe there's user training involved to get the most out of your AI, where you kind of have to meet it in the middle in order to really leverage the power of it. I'm not the engineer in the group, but I think that with the right data sets, we can make huge strides forward that we would find hard to fathom today, right?
And hey, Will, like as AI becomes better at doing more and more, I do hope that then the human volunteers will have even more fun tasks. I'm just making stuff up on the spot, but hey, maybe enjoying the night sky with your kids and pointing out,
right,
the different constellations.
Let's just keep
how are we going to do that?
bar, right?
Exactly.
I think any AI solution that we create, we must co-create with the users. I think the industry players and technology developers cannot do this one-sided or in isolation without the users. It's easier, I know that we all agree here. It's easier said than done, actually, because again, we need to go back and make sure that everyone within the disability community, regardless of location and language and social status and whatnot, have an equal opportunity to participate in this AI data harvest efforts, so that we can produce technology that will truly work for everybody.
Yeah, and that is again going to my next question then. Do you, in your practice, involve target audiences in developing and improving your products? And if so, could you please elaborate on how you do so?
So Microsoft consider disability as a strength. So in the technologies that we develop, we involve persons with disability from the designing to the testing, as well as we have communities that provide advice to our engineering teams on an ongoing basis as well, to ensure that we create technologies that are meaningful to the user. So yes, and I'm very proud and glad that Microsoft has taken this approach, because persons with disability are seriously impacted by the technology that the industry players bring about. It either going to work or not going to work, and it would be good if people with disability and users everywhere can participate in a journey of creating that technology, so that we can ensure that the technology indeed work well and help everybody stay productive. So this is a value that I'm glad that Microsoft has cultivated under the leadership of Jenny Lay Fleury, our Chief Accessibility Officer. So it's been gratifying to see.
Yeah, and I mean you've got a majority of this is Will, by the way, a majority of blind or low vision people even on this panel today, and I think that tells you something, and that's probably where I think we'll all agree is, it Be My Eyes at least, we don't do anything without involving the user. We don't release anything without testing it with the users. We base a lot of our development roadmap on feedback, and it's entirely ingrained in what we do.
I think this is Karthik here from Vision. I think what we're a really small startup, right? But we also ensure that at the end of the day, we begin with the users, because we've seen that oftentimes when we go create, wherein we get people who are, from different walks of life into a single room with the designers, with the developers, that in fact helps us create or saves us a lot of time in terms of which direction to take a particular feature in or take a particular product in, right? For example, on the Envision glasses, we just released a feature that allows a visually impaired person to move their document before to get the document fully in frame in one go, so that they don't have to end up taking pictures of the document over and over again with the glasses. So this was a feature that we first came across because this is a feature that's there on the app. It's also there in an app like Seeing AI. And users wanted to have the same experience when they were using smart glasses. And so no one has ever built something like this for smart glasses at all. No one's ever built a document guidance system for people using these kind of glasses. So we had to first start, and even the AI team didn't know what they should actually end up building. What kind of a model should they build? Should they build a model that works on a real-time video feed? Should they build a model that works on images? And those are the questions that get answered when you put the users from the community, from different walks of life, right? Again, that's also important because you can get, I can get a lot of, visually impaired people who are extremely tech savvy, but then can I also get the 70-year-old grandma who's not really, into technology also in the same room as a 24-year-old programmer who's visually impaired and has been around technology since the day they were born, right? So we work really hard. And since we're based out of the Netherlands, we try to do our best to get people from different cultural backgrounds as well to be part of these co-creation sessions. We invite them to the office, and one of my favorite moments that happened over the that happened in March was we actually had different versions of the same model for the document guidance ready, right, with different frames per second processing times for these, right? So we actually basically connected the glasses to my laptop, handed each user a pair of the glasses that was running a different version of the model itself that had different frame rates. And we could see like which model works best for people based on what they think. So if, for example, some users preferred a faster frame rate but weren't so caught up on accuracy, those were people with, like, for example, some amount of vision, some low vision users. Then there were people who were completely blind and who didn't have the residual vision to be able to understand the shape of the document. So they wanted higher accuracy, but they were okay with lower frame rates. So even those kind of trade-offs become very evident when we start talking to users. And that's sort of been that's the way we've been building things from day one, because ultimately, unlike Saqib or Anne or Will, I'm not a visually impaired person. So it's incorrect for me to assume that, I know exactly what, someone who's going to be actually using the product wants. And so that was the main driver for us. And, this whole example of this feature is one of the many examples that I can, talk about, with regards to co-creating with users, right? And that, stuff or that conversation directly impacts the work that we do and the priorities that we pick, because we're not a company with a lot of resources. So we have to be very picky, and the user input helps us prioritize that a lot and build products.
And, even with a team with people with vision impairments on the team, there is the broad spectrum of lived experiences of people with all sorts of different levels of vision or different levels of tech ability or just different life backgrounds. So yeah, there's nothing without the user in the work we do, because that's the whole point of creating assistive technologies, is, well, to have the biggest impact for the users. So whether that is in terms of the ideas which might come from a very real user need, through to the design of the user experience and or the machine learning models, that all then comes from having users involved to some extent in the design, but then even more so in the testing of making sure that whatever we do come up with really is something that provides the value we want it to, because if it doesn't, then yeah, there's no point. So I think working with users throughout the process of a variety of different users is really important. And, that might be just over the internet. It might be people we invite for a particular study, or that's the general feedback we get by email, a number of different avenues we use to be able to do that.
Thank you for that. So my final question for today is, I'm sure there are people in the audience as well as students who are wanting to get involved in the work that you do. So could you please share a bit about, how students and others can get involved? For example, what skills does your team look for when recruiting, and how might a computer vision or accessibility person make themselves appealing to your accessibility team?
So this is Karthik from Envision. To be honest, and to put it bluntly, they need to give a damn, right? That's the kind of people who we really want to have and want to attract, and those are the people who we have seen from our experience. Again, since us being an early stage startup, we don't get like a flood of applicants to pick from, but even the ones that we do reach out to, we have always ensured that they really care about the problem that that we worked on. I think the second skill set for someone who really wants to enter the space, it's a cliche, but we really want to have these T-shaped people, right? T-shaped people are people who have a deep expertise in one area, but then are also able to go ahead and work, well, or be able to expand their skill set in other areas, or be able to do the basics in other areas really well. So while we expect a computer vision engineer at Envision to be really good at computer vision, we also expect them to have certain amount of soft skills, right? So we put we have computer vision engineers actually interacting with our users almost on a daily basis. The things that they build, goes directly into the hands of tens of thousands of people across the world. So they need to be empathetic enough to talk to them on a daily basis, empathetic enough to understand things from their perspective, and have the soft skills to basically work with people itself. And for example, if we're talking to someone who's a designer, they need to be able to understand accessible design really well. We need them to be really good at that, but at the same time they need to be able to understand the limitations of technology and how they can basically communicate the limitations of those of that technology, or computer vision specifically here, to the end user, and be able to have a conversation or be able to indulge in user research based on what the technology can do, right? So I think it's important for people to really care about the problem, and for people to be able to have one area where they're really skilled at, but then also be ready to dip their hands into many other areas as well, most specifically on the human side, right? So we've come across a lot of typical lone wolf programmer types who just like to sit in a room and then say, I'm going to hash out code. You tell me what I need to do. I'm going to just hash out code, and I'm really good at that. And we've passed on those candidates because of the fact that they don't have or they're not willing to really go out and talk to users and understand things from their perspective, right? And that's the kind of person that you should be if you're looking to get into accessibility.
This is Will. I'll just add on to what Karthik said. Microsoft is really a leader in building inclusive teams, so I'll give them the final word. But from my perspective, I think my advice would be get to know the history and the people who have been working on building technology for people with disabilities over the last few decades, because it's a small industry, it's a small group, but there are some just incredible innovations and incredible thinkers and people who have spent their whole lives doing this, and so much can be learned from them. And I think, and even though it's sort of just a small slice in this mainstream technology field, I really think a respect and kind of knowledge of those who came before is really important before you dive in to this stuff.
Yeah, so we're currently hiring for Seeing AI, so do email seeingai@microsoft.com if you're interested. But what do we look for? Really, as people have said, it's this really caring about helping people, improving the state of the art, and being technically at the top of your game. So I think about human-centered AI as this rare skill set where not only do you understand machine learning, but you also understand how to apply that to real-world problems, especially ones which involve new user experiences, because it's not about just taking some data and training a model to predict, given more data, create accurate predictions. It's really how do we actually enable people to do more? And that really depends on the human experience of how is someone using technology, where are they, what do they understand, what is their situation? And so it's bringing all of that, understanding the people, understanding that and prototyping experiences, plus understanding machine learning. And that combination is just so powerful. But yeah, as others have said, a lot of it is just adapting with time, because what is relevant today might change tomorrow. At the end of the day, we're all about solving problems, regardless of which technology we end up using or what particular field is the most interesting at the moment in time. So that ability to learn and just keep creating solutions that help people is invaluable.
I'll just leave with this. Use technologies. Number one, use it. Because whether it would be any industry player, Microsoft or any other player in the industry, when we create technologies, we hope that we would be able to put it in people's hands, and we thrive on the feedback of the users. And there are so many ways to give us feedback, right? In the product itself, you can give us accessibility feedback. You can reach out to the Disability Answers Desk or the Enterprise Disability Answers Desk, or you can tweet to us at MS Enable. So there are so many ways to give us feedback, but use our technology and keep the feedback coming. And I think the skill that we're really looking for is, yes, we're looking for technical skills. Like, you have to be really good at whatever engineering discipline you're at. You may have to be really good about assistive technology, but I think most importantly, the skill that we're looking for is the ability to partner, the ability to form the relationship, the ability to build empathy and co-create with others. Not working in isolation is the golden ticket to bring forth accessibility in the technology space. So the more you can come in with new point of view, and then be willing to take feedback as well as you work to advocate or improve accessibility, because sometimes we all quote unquote have tunnel vision, and we have some preconceived notion of how things should be or how things have always been. And I just urge that people who get into accessibility, yes, we need to develop and design products that respect the industry practices or the usability experience that's been in the past, but we also need to look ahead and innovate. So let's be open-minded. As Satya often said at Microsoft, let's have a growth mindset in this area and then be willing to partner. Then we can come together and create this beautiful harmony to ensure that everyone can use the technology as they should be able to.
Well, that brings us to the end of our discussion today, and we're so grateful to each one of you for sharing your valuable insights with our audience today. As it was for me, I'm sure it was extremely inspiring for our audience as well, and we look forward to following the progress you all make with the products and services for the community. Thank you again for your time.
Thank you.
Thank you, Samreen.
Thank you very much.
Next panel will begin shortly. 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 The show will begin in 1 minute. The show will begin in 30 seconds. The show is beginning.
Perspectives of computer vision researchers on the challenges and opportunities for advancing visual interpretation technologies. Moderator, Daniela Moschetti, Senior Researcher, Microsoft. Speaker, Marcus Rohrbach, FAIR Research Scientist, Meta AI. Speaker, Andrew Howard, Senior Staff Software Engineer, Google Research. Speaker, James Coughlin, Senior Scientist, the Smith Kettlewell Eye Research Institute.
Hi, and welcome to the third panel discussion of the VizWiz workshop, everyone. My name is Daniela Moschetti, and I'm a machine learning researcher at Microsoft Research in Cambridge in the UK. And today I have the pleasure of welcoming three other fantastic computer vision and machine learning researchers to the stage. So we have Marcus Rohrbach, Andrew Howard, and James Coughlin. Now, I think we all know that there are no shortage of ways in which computer vision technologies can really support and empower the blind and low vision community. And so I'm really excited to have all three of you here today so that we can start to dig into the cutting edge research that's happening in this space. What are the key challenges that we're facing? And also looking forward, what does the future hold in this space? But before we dive in, I wanted to share a little bit more about each of you for our audience. So first, starting with Marcus. Marcus is a research scientist at Meta AI Research with a PhD from the Max Planck Institute of Informatics. Marcus is most well known for his work at the intersection of computer vision and natural language processing. And over his career, he has driven key progress in visual question answering, language grounding, and generating descriptions about images and videos, in particular movies. All of which are really highly relevant areas for the blind and low vision community. In fact, I myself have done a bit of work as well at this intersection of computer vision and NLP, and I think each of these fields alone have many open research challenges. And so when we kind of bring them together, we get even more complex questions that arise. So yeah, I'm really looking forward to what progress Marcus can share with us on this front. Our second guest is Andrew Howard. So Andrew is a senior staff software engineer at Google Research with a PhD in computer science from Columbia University. Andrew is most well known for his work in mobile-friendly deep learning models. So starting with MobileNet, then MobileNet v2, then MobileNet v3, and also MNASNet. His work really has been broadly adopted in deep learning packages like PyTorch and TensorFlow, as well as across a host of mobile phone platforms and apps. And I think many of us who work in computer vision research do have the intent of, deploying our models in the real world. And I think in many cases, a crucial part of that is obviously getting them to work on resource-constrained devices like mobile phones. So I'm really excited to hear more from Andrew on the latest and greatest in deep learning on the edge. And then finally, I'd like to welcome James. James Coughlin is a senior scientist at the Smith Kettlewell Eye Research Institute with a PhD in physics from Harvard University. James has been at Smith Kettlewell since 1998, and over this time has developed a really wide array of impactful technologies for the blind and low vision community. Some of these include guidance systems at traffic intersections, hazard detection for blind wheelchair users, wayfinding using machine-readable signage, interactive 3D maps, and object recognition tools. He has also driven fundamental research in computer vision, particularly graphical models and belief propagation for visual search and semantic segmentation. And I think as a person who really crosses, the spectrum from fundamental to applied research, I think James will be able to offer a lot of useful insights in the learnings he's made along the way. So yeah, welcome all. It's a pleasure to have you with us. And I think now that the introductions are out of the way, we can really dive into the panel. So to kick us off, and for the sake of the audience, I think it would be good if each of you could share a little bit more about your current line of work, how you got into it as a computer vision researcher, and a little bit about the problems that you're working on at the moment. So how's about we start with Marcus?
Hey, yeah, thank you. Thank you for the introduction. Welcome, everyone. Yeah, I've been working basically on the intersection of vision and language since my master's thesis, and then continued working on different aspects of it. And most recently, we've been looking into, on the one hand, how to scale models so they can, like multimodal models, so they can do multiple tasks, which I think is also useful in any applications, and learn from sort of unsupervised to self-supervised data. That allows to sort of increase the amount of data we can learn from significantly. So that's sort of one line of research, and then another line which I sort of very recently just started this year is looking into the reliability of models. And with that specifically, I mean, if a model answers, for example, a question in a visual question answering system, sort of giving an answer, most systems right now just focus on predicting the most likely answer, but it might be not a good idea for some use cases, such as assisting a user or assisting especially a user with visual impairments, because the system might be wrong and the model doesn't really have a good idea when it's wrong and when it's right. So we have been looking into how good are models in predicting if they are right, and then they can answer the question, and predicting when they're wrong, or they can alternatively abstain, but just said, okay, I can't answer this question. I actually found, at least for state-of-the-art visual question answering models, that models are basically very bad at that. And we've been starting looking into how to improve that, and we have sort of initial work on that, but we're continuing working into how to really get that off the ground.
Yeah, that sounds fantastic. And yeah, when we think about, on your last topic of reliability, that's so important for people who are blind or low vision, because of the often safety critical scenarios in which, they may be asking a question about a visual scene in front of them. So yeah, I think those are really important directions. Thanks. Andrew, how about you? I know you're working very much on the edge, as they like to call it. So yeah, excited to hear a bit more about that.
Yeah, great. Thanks for the introduction and also the invite to speak. I think this is a great topic. Well, let's start from the beginning. How did I get involved in machine learning? I took some classes in undergraduate, and it was very clear that was the exciting place to be. This is, so then I did my PhD at Columbia in machine learning, and this was kind of before deep nets were a big thing. Then as I got in industry and kind of deep nets started to show themselves, it was kind of really clear, like, hey, we gotta, go tackle this problem here. Deep nets are the future. So I kind of independently worked for a little bit and did well in, say, the ImageNet challenges with maybe an eye towards a startup. But then a nice opportunity at Google came, and so then I joined Google. And they had a very exciting problem. How do we do this efficiently, on device? And so that was kind of how MobileNet was born. And basically, my team at Google is a kind of an applied research team where I would say 50% of our work is more about how do we move the field forward on the research side, but it's always targeted at, how do we solve a problem that's kind of useful for Google products and the industry in general. So kind of 50-50 between doing actual work that will go into the world and academic work. And then the two kind of inform each other. So one of the kind of challenges that's happened is, in the beginning, everyone kind of had a CPU on mobile devices, and, we could solve that well on there. And it's kind of a combination of how do we start from first principles, neural nets, how do we strip them down to the bare minimum and kind of make sure they map well to both the hardware and software available, usually targeting Android ecosystem. We're a little more focused on that. Now, as phones have gotten more mature, there's more and more kind of custom hardware. So some of the things that work well on CPU don't necessarily map well to running well on, say, accelerators. So one of the themes we've been investigating recently is how do we make kind of more universal models, models that out of the box are just going to kind of work well on any hardware you want to deploy them. Again, focusing more kind of on the Android ecosystem. And that's a combination of research topics around, again, what are the useful and efficient building blocks for a neural net, but then also a more applied aspect of, do the benchmarking, tune the model specific to the benchmarks on the hardware. And then what's kind of nice is, we get to publish that, we get to release open source models, but then we can also feed it in, say, Google products and kind of help a large number of people in the world. So that's kind of one theme, these universal models of efficiency that we're working on. I guess we have some other projects around how might we do more of a conditional computation, since not every vision task is as challenging. So simple things can be solved with less computation, more complicated things with more, and possibly more specialized. So that's kind of another theme. But yeah, in general, my work's basically around efficiency. How do we get kind of the highest accuracy for the least amount of cost?
Nice. Yeah, that's a great overview. And I think, if we kind of think about, I guess, the great diversity of devices, the heterogeneity of all the different devices that we use in our daily lives, having kind of universal ways of making, AI models on them work more efficiently is a really important direction, I think, going forwards. Thanks very much for sharing. James, love to hear from you.
Thanks a lot. And thanks also for inviting me to this panel. It's a lot of fun. I'll say a little bit about my background. I was sort of squarely in computer vision, doing my PhD thesis on things like deformable templates, stuff that preceded the deep learning, machine learning revolution. I always with an interest in geometry, and in my postdoc, I did this Manhattan World work. And back then, the interest was mostly theoretical. My advisor was thinking about possible applications for blindness. I think he was envisioning, a blind person navigating in an urban environment. A lot of urban environments have XYZ dominant structures. How might we interpret the edges? And that's how my answer to him was the Bayes net behind Manhattan World. And over time, I realized that the whole world of accessibility for people with visual impairments was just a great application for computer vision. And early on, I sort of faced a choice between, do I want to target people who identify as blind or people who are low vision? And the dividing line is largely what kind of interface do people want. If you are blind, you're going to want audio or tactile interfaces. If you're low vision, you're going to want something zoomed in, enhanced video, that kind of thing. And I thought, well, low vision people already have a number of tools at their disposal, but if I could do anything even small with computer vision, I could perhaps give information to a blind person that they would have no other means of obtaining. So I sort of focused mostly on blindness. And a lot of the themes over the years have been sort of geometric things that, where some sort of geometry is required. Like an early project was on navigation at traffic intersections and understanding where a person is with respect to crosswalk stripes on the ground. So for, just to say, my career has kind of gone from the theoretical side to more applied angles. And by the time I was doing, a Bayesian barcode reader, of course, I've always loved Bayesian reasoning. And this was probably begun in 2008 or so. But I was also very aware that at that time, there was no way for a blind person to, let's say, distinguish between two cans on their shelf. One could be tomato soup, the other could be, lentil soup, very different products. How do we read a barcode, noisy images, all that kind of thing? And I began, in those days, the N95 was just powerful enough that you could actually port some algorithms to it, and began doing user studies and realizing that the real work is to identify the overlap between, what does a blind person need and, where might methods from computer vision actually be practical in helping to meet that need. And it's always a big challenge to find that overlap. And so, more recently, I've been focusing on two main projects. One is indoor navigation, or really, navigating in any GPS-denied environment, and trying to focus on a lightweight approach that is relying on a small amount of information. So perhaps the best way to solve that problem, if you just want good localization performance, would be something where you scan, the entire environment and you make a 3D model and do localization based on that. But something which is more lightweight, that is more likely to scale and doesn't require connectivity, perhaps with sensitivity to privacy. Perhaps there's a building that you want to have access to, but maybe the manager doesn't want you scanning every portion of the building, but they can hand you a two-dimensional floor plan. So that's one of the projects I'm working on right now. And a big theme running through all of this, which is maybe a little bit, related to this whole panel, is that an image taken by a blind person is very often, not going to be the image that you as a computer vision person hopes it would be. Aiming a camera is a huge theme in my work. And so, as a researcher making an application intended for a blind person, I don't want to assume a blind person can know where to aim. So I'm giving sort of generic feedback like, hold the camera forward, don't tilt it down, don't tilt it up, try to acquire usable images in that fashion. And another project that I'm working on is what we call Cameo, camera input output. And this was a project suggested to me some years ago by a blind person who said, oh, James, can't you use computer vision to give feedback on, let's say, a three-dimensional object like a three-dimensional scale map? Or two-dimensional tactile map. And the idea being that you really want to sort of close the loop. A person who doesn't have a lot of vision is going to feel comfortable exploring something tactilely, but wouldn't it be great to have audio labels to orient the person to, you're touching a relief map. Well, this is, one mountain peak. This is another feature on the map. So that's another project I'm working on. And again, I'm thinking a lot about very practical issues like, okay, this is currently in the form of an app, and the prospect of having a blind person aim a camera fairly precisely at a target object is kind of a challenge. And so these are important considerations that come up. And the general theme of these projects is just promoting accessibility whenever possible. And so while the first rung of the ladder is perhaps to have someone else, annotate an object so that it's then accessible to a blind person, the next rung above that is to make an authoring system that is completely accessible. So a blind person can author it themselves if they want. So that's an overview of where I came from and what I'm doing. So thank you.
Yeah, fantastic. You brought up a lot of interesting questions and a lot of interesting areas, I think, in particular for accessible tech. I mean, just going to one of the points you made around helping a person who is blind aim a camera. I mean, I think the kinds of images that we see in the real world taken by people who are blind are really quite different from the images we see in these computer vision benchmark data sets. And a big challenge there is, I think, making sure that we recognize that mismatch and are really building systems that work for the real world, not only on these benchmark data sets. Fantastic. So that was, I think, a very nice starting point for our discussion. Next, I'd like to hear from each of our speakers a little bit in more technical detail around the kinds of methods that they're using to tackle these problems that they've mentioned, or these areas. And in particular, the kinds of errors or limitations that you encounter with the methods that you use. So perhaps we can start, we'll shuffle the order a little bit. So perhaps we can start with Andrew. If we kind of look at these mobile deep learning networks, how do they work? What kind of makes them so mobile friendly? In what scenarios are they failing? It would be great to hear a little bit more. Our audience, I think, would enjoy to hear a little bit more about that.
Yeah, all right. That's definitely an interesting question for this area. In some ways, neural nets basically there's a trade-off between accuracy and resource usage. And, that could be resource usage, which is, latency or power, could be size. Generally there's a log linear relationship between these things. And whenever you're able to kind of find an improvement that is, more efficient, you can also find a more accurate one. So you basically have a curve, the Pareto optimal curve. And as you make an advance, the Pareto optimal curve kind of moves out further. So how does one move the Pareto optimal curve out? Some of it is, go into kind of first principles on how one might design an efficient network. And so how did we get to kind of mobile nets? It kind of came from the insight that, aspects of this were in the literature as I was developing it, that you could factorize networks into something responsible for essentially mixing the pixels and something responsible for mixing the channels. Hopefully not being too technical here, but and by doing that, you actually get a lot of improvement at speed. And one of the nice aspects is the part that mixes the pixels are essentially one-by-one convolutions, which are implemented as matrix multiplies. Now, matrix multiplies have been hyper-optimized in every format out there. That's like well understood, well worked on. So it's kind of moved most of the computation from a convolutional operator into a matrix multiply, which is simpler to implement. In fact, transformers, which are very popular for NLP and now for vision, they use a lot of these things as well, one-by-one multiplications. So we got essentially a nice advance by factorizing less total flops and then flops that map better to the hardware and the software. So that was kind of a nice win. And, those are the pieces that are typically getting used pretty broadly now. The small caveat is we still had to mix the pixels, and that's where we call these kind of depth separable filters. And that was kind of the challenge to make sure there was a good implementation of that broadly across the ecosystem, because that was a more kind of unique operator. So this goes more over to the general problem that we're having as we're trying to make advances in efficiency. So how do we measure advances in efficiency? So again, we could measure, are we more accurate at the same number of flops? But sometimes those flops won't actually map well to an implementation of the hardware and the software. Mm-hmm. So that may be interesting for academia, but for actually, shipping something and making an impact on the world today, it may not be the right solution. Might be the right solution in the future when you get good support. So this kind of iterative process of thinking about what are the pieces that will give kind of the best neural nets in the most stripped down version that then also map to the hardware and the software is kind of how we dig in. And so what are the tools that we use? Some of it is just first principles and thought experiments, followed by iteratively running experiments to verify that. Some of that is actual benchmarking. Some of that is then also using AutoML to kind of tune the pieces that we find to be useful into their kind of optimal shape. So this is kind of the research project as we try to create kind of best practices to do efficient networks. When I then engage with, say, a product team or something more applied, usually that's a little more linear. It's like, here's how well we can do now based on your requirements for the project, and, kind of follow the best practices on how to do that. But then if there's some gap between what, say, a product needs and kind of what we're able to deliver, that's another research opportunity, And so being able to take kind of potential product needs and map it back into the research community and then kind of do it as a more general research project, put it out in the literature and hopefully inspire more people to look at those projects. That's been a kind of a really nice cycle. So maybe I can pause there.
Yeah, nice. And I think that that really is the, what would you call it? Not the perk, but the real nice aspect, I think, of working in this kind of on the spectrum of fundamental to applied research, because you do get that nice loop where you're doing research, not for just the pure sake of research, but actually informed by kind of the real world needs, all the things that product teams want. So that's, I think, really a nice aspect. And I think James touched on that as well. Great insights into the mobile nets. I guess just a question from my own curiosity, as we see these mobile phone cameras, higher and higher res, they have these enormous images coming through now. Do you think the mobile nets are able to kind of make the most of those large images, or are we still in the space where we're kind of mapping these down to, smaller images, which will then work better and faster? So yeah, I don't know. Is there a trade-off or a tipping point where, image size? What's the image size that current most efficient models work with on a mobile phone?
All right, that's a very interesting question. All right, so in general, I would say it's problem specific as to kind of what is the sweet spot for resolution versus accuracy. So, we use kind of say ImageNet or, COCO as kind of our lab rat, if you will, but that doesn't 100% map to real world problems. It correlates, and making progress there does tend to translate. But the idea of resolution for, say, an ImageNet problem, resolution's less useful there. However, things in computational photography or things maybe if you want to do background blurring for one of these meetings, you got to have your edges really kind of clean. And so then higher resolution really benefits there. So these kind of mobile models, and they can be really scaled up as much compute as you have. So it's in some ways it's compute bound. And so as we get more and more accelerators, you can run on higher resolution. But then the gotcha is the accelerators are now a little bit memory bound. And then more pixels mean more memory. So some of it is like, when will the hardware be where you need it? But then what value do the extra pixels bring are kind of dependent on the actual problem.
Yeah, that definitely makes sense. I can totally imagine that different applications have kind of different resolution needs, let's say, or as you say, what is the value add that comes from those extra pixels relative to how much compute you're spending to process them? Great. Marcus, so you're working very much at this multimodal intersection, and there's been a lot of recent progress in this space with, I think, models like CLIP and DALL-E. And so, I'd love to hear a little bit more about the kinds of models that you're using at this intersection. How do they combine vision and language, and where are they failing? What are the kinds of things they're not working for just yet?
Yeah, so we are working also on very similar technology, like using transformers, as also mentioned by Andrew. One thing we have been trying to solve is not just solving one single problem with a single model, but trying to have multiple problems which a single model can solve. So vision-only problems, language-only problems, and multimodal problems. And I think the challenge is especially to transfer it to tasks which are especially small with respect to the data. So, for example, if you think about a VizWiz data set, which this workshop is also hosting, it is comparatively small. So it's actually a challenge to transfer any models on this kind of task for assisting visually impaired users. So I think this is sort of a major challenge to understand how can we transfer from a large supervised training data or even larger unsupervised data. How can we transfer knowledge and data, given that the questions are different, images are different. So both the language and the visual side are basically changing, and we have to then also sort of understand how the model has to change. And that, similarly to what I mentioned earlier, then also the question is, if models operate maybe somewhat reliable on a large known set, how do they operate on this sort of new smaller set, and how can we solve that problem? And in our research, it's a largely unsolved problem, so there's lots of work ahead. And that will be also critical, I think, before one can sort of widely apply that and give that to users, basically.
Yeah, I think that's exactly right. And I think the point you're making around, I think it touches on what James was saying. around really, this difference between perhaps this large supervised data set that we have, and really thinking about the ways in which that data may differ from the kinds of real world data that a person who is blind will collect, for which we might only have a very small subset. And so I think that is a very relevant challenge that we face in getting computer vision research models kind of working in that real world because of that mismatch. So I think that links nicely with what James mentioned earlier. James, I would love to hear a little bit more about the kinds of methods that have gone into the tech that you've built recently, and sort of what the limitations or errors you've encountered with these methods are.
Sure. Yeah, for the indoor navigation project, it's kind of a classical approach we're taking with, recognition of visual landmarks with YOLO, particle filtering, and something which I never appreciated, maybe 5 years ago. I wasn't aware how powerful this was going to be, but visual inertial odometry, which of course is standard on any smartphone now, which is a very useful input to have to your particle filter. And with that, we have a two-dimensional floor plan. So the components are, fairly well understood. There are a lot of challenges. Some of them are expected, some are unexpected. I mean, one of the expected challenges is that, recognizing visual landmarks, that sometimes you may have expectations about what kind of error rate you're going to get, but you may not attain that low an error rate right away. There's a challenge that's very pragmatic, but we're developing on iOS for our experiments, partly because a lot of blind people prefer iOS over Android. That's historical. It's changing slowly, because iOS, I think, was accessible very early on, even before Android. Android was accessible with screen readers and so forth. And developing on a smartphone platform, it's a bit of a hassle. I think of the computer as kind of the first world for programming. You have all the programming tools you like. You can visualize things very nicely, 3D plots. You can mouse around, beautiful. But then when it comes time to port to the phone, it's difficult. So on the laptop or desktop, maybe you've had the luxury of using Python, and nothing against Swift, but Swift has to interface with C++, and suddenly you have a few different versions of the code lying around. And of course, you can visualize things on the fly on a phone, but that's the visual real estate is very small. So it's kind of a challenge, sort of iterating between these different forms of the code. And then just at a very high level, the very notion that, a blind person will use their camera on their smartphone to navigate. I mean, that's not a given. That's kind of an assumption that I made, knowing it was a questionable assumption. And what I found talking to some blind people say, I have no problem holding the phone while I'm walking. I'm always texting while I'm walking, or I'm always, using Google Maps while I'm walking. No big deal. For other people, though, it might be just, a reason they would never adopt such an approach, because maybe you have one hand already holding the guide dog harness or the cane or something. Maybe you have groceries in another hand. Oh, you want to hold this in another hand? That's maybe not going to work out. And so it's kind of made me more and more impatient to see wearable cameras become more widespread than they are, and in a way that would be perhaps integrated nicely with the user's phone. And then another sort of high level thing is, even if my algorithms are working perfectly, localization is working really well. That's great. There's a big question about how do you want to convey that information to a blind person. So I think a lot of experience that we've had in the field of accessibility over the years has been directed at sort of GPS enabled navigation, which is great. Typically, you're getting 10 meters accuracy, maybe 5 meters, even a little bit better nowadays in urban settings. But it's not pinpointing you. But in an indoor setting, you might actually want to tell the person, oh, you want to enter this door, not the door to its right. And even though they're separated by only a meter, they're very different destinations. So whereas before you could, in a GPS sort of domain, you could give broad instructions? How do you give more detailed instructions to a blind person? And, again, the system may know everything precisely geometrically speaking, but you don't want to burden the user with overly detailed instructions. And of course, this is often in audio form, and a person is going to have to listen for ambient sounds. That's a very important thing for safety. And, there are some conceptual tools that are very helpful. If you're in a corridor environment, it makes total sense to say, proceed down the corridor. And there's this technique that's used that's very common called shorelining. For instance, if you have a cane, you will, sweep the cane back and forth while you're walking, and the cane will kind of help you keep track of, oh, the wall is right there on your left, and you're walking pretty straight. And then the next concept could be, oh, there's a junction, turn left at the junction. Okay, the cane can help you figure that out. But now if you're in an airport or some other wide open space, what directions do you give? You don't want to burden the user with, adjust your path by 2.5 degrees and, that kind of thing. So it's very unclear, I think, what the optimal user interface should be. And of course, different participants in your experiments will have different preferences, or circumstances may dictate that, hey, I don't need details this time, or yes, I do want all the details. So that's just some examples for one project. The other main project I'm doing on audio labeling. So the approach I'm taking for the time being, at least, is to do this as a three-dimensional thing. You have an object, like a tactile map or something, and the camera is estimating the pose of that, 6 degrees of pose, and then you have something like a stylus or or the person's fingertip, and you want to understand, well, where is the fingertip or stylus pointing in 3D, and how does that relate to the 3D object? So it's very basic geometry. But I want to think in terms of making software that works on as many cases as possible. And so I'm hoping for the day when pose estimation is just working really beautifully. But for instance, here's an object, a daily object. My mug has very few visual features, and I don't know if there are a lot of pose estimation algorithms that would run out of the box on something like that. And certainly, although, for instance, iOS has ARKit, which has a 3D scanning feature and will do pose estimates, it's looking for SIFT-like feature points, sort of older technology. So what I've done in the meantime is to say, well, let's go very low tech and let's use markers, Aruco markers, that kind of thing. And so, because I want sort of lowest common denominator, no matter how featureless your object is, I want to be able to sort of track the pose while I am simultaneously exploring, more advanced approaches. So anyway, that's a technical detail for that project. And in terms of sort of the user experience and what skills are needed, again, like my current approach is assuming that the camera has a clear view of the entire object of interest. It's not that easy, for a person who's blind to make that happen. And I also want to point out that even people with normal vision, we've all had the experience of maybe taking a selfie, and maybe the sun is blinding you. You can't see, the display of what the camera is showing you too well, and it's quite difficult, actually. So I think sighted people, we all know and pay lip service to the fact that aiming the camera is important and it's challenging. But I think we tend to forget the degree of our reliance on visual feedback to accomplish that aiming. So anyway, that's a sort of a technical challenge that comes up again and again on that project.
Yeah, thanks, James. I think there are a lot of connection points to some of the work from Andrew and Marcus. You mentioned, for example, visual inertial odometry. I think this is kind of, if we zoom out, it's really taking the perspective that, maybe building these systems, it's not just about the data stream that's coming from the camera, but really about how we can integrate all these other different modalities, whether it's natural language inputs or outputs, whether it's, the gyroscope or accelerometer, all of these additional pieces of information which might help us help the model ultimately deliver a more robust and reliable output or response. I think that's a nice connection point to some of Marcus's work. But then another point that you mentioned, I think in one of your earlier answers, around it's not just about us sitting in as researchers, us sitting in our research worlds and imagining what the experience should be. It really is about kind of mapping really testing them out, testing out those assumptions, making sure that they're, working for users, conducting user studies. You mentioned that in your one of your previous answers. So I think that's really important. It's not just about sort of keeping separate, keeping us as computer vision researchers separate from, the actual end users of this technology. It's about bringing us much closer to one another so that we make sure we're ultimately building technology that really serves the needs of the community. Great. So let's zoom out a little bit. And so I think, we've kind of got a nice base for, I think the audience will now have quite a nice basis or understanding of, kind of the work that you're doing, the challenges, technical challenges that you're facing. But I think given that you all, have worked in the computer vision research space for a long time, I think it would be interesting to kind of zoom out and hear a little bit more broadly about what you see as kind of the key turning points which the computer vision community has taken over the years or decades. Kind of those pivotal moments which have shifted the community in key ways and have really enabled us to address some of the challenges that end users or people who are blind face. Maybe we can start with Marcus.
Yeah, I mean, maybe I think there's maybe two things. On the one hand, the emergence of larger and larger data sets, especially in the vision and NLP community. But then second, obviously also especially in the multimodal setting, the start of deep learning, and especially for I guess it was for all the different machine learning communities, but also for the multimodal community, because it allowed to sort of really integrate visual and language signals, which was much more difficult before, because in vision, there was completely different technologies than in language. And so maybe most recently, this actually has come even closer with the emergence of transformers, where it's not just sort of the same system, it's actually the same model basically used for both vision and language signals. I think what we are now at is we are sort of really scaling to very, very large data sets and very, very large models. And there seems to be some gains to be made, but I think the next question is sort of how can we even do without those large data sets? So how can we do without these super large data sets and super large models and still perform very good? And I think there's sort of lots of advances to be made in the next coming years on sort of that side. And sort of the other side, I think we're sort of a big major challenge, I think, is in privacy and safety of the systems. And then I think that has, again, multiple dimensions. So it includes, for example, if you train on very large data, you don't really know what the system is trained with and how it might operate on certain points. You might not have seen it operate in certain dimension, but that might actually have seen this kind of object before in some far distance pre-training data. It might suddenly be sure that it's something, but it's not. Or it is. So it's, I think there's lots of challenges to understand what those models can do and what they can't do, especially in the safety critical situations. If we want to deploy them for users which use them beyond playing with them.
Yeah, definitely. Some great points there. And I agree. It's kind of nice to see models like Transformers really kind of bring together a lot of the work in, different parts of the community and almost serve as a universal model to rule them all. I think that's been quite a cool thing to see over the last year or so. James, how about you? What have been sort of the key over your career, the key turning points in the computer vision community?
Yeah, I mean, I think some of them are probably obvious, and I'll just say them really quickly. Computer vision algorithms used to be things that ran on desktops and laptops only, and the smartphone revolution has been really incredible. And of course, in the early days, we could eke some performance out of a Nokia N95, and then the iPhone came and all that. And I think some of the importance is, of course, it's amazing that you can run this on your phone. That's great. It's portable, it's mobile, but it's also been a real sea change in the way cameras are used. A camera used to be something that maybe you kept charged for vacations or for special outings, whatever, wasn't always by your side. Now a camera is a daily tool. I remember very early on doing some of this research, just my mere presence, like holding a camera in a store or something. I mean, the store owner would question me, "What are you doing?" And there was, a note of concern. And fast forward to now, when I would think, especially if you're, a blind person, you're holding your camera, you're scanning. I don't think people are going to suspect that you're up to no good. I mean, there's an assumption that this is a tool that's really useful. And so now you have cameras that are not special tools, but they're everyday tools. And so you have all this different data than you used to. And of course, the old training data used to be very nicely composed images. And now you have these images that are, that are much more informal, and a range of conditions limit their usability. So I think that's really great. Also, I think there's an increasing sort of tolerance of the fact that we're asking machines to solve tasks, and the tools we use, algorithms, AI, are imperfect, and that's not necessarily a bad thing. So I think there's an expectation that if you point seeing AI at something, usually works, but every so often it doesn't. It doesn't mean you throw it away. I think there's just more tolerance, especially maybe among the younger generation. This technology is growing. It's not perfect. And then just the other turning point, which is it's less big, but it's big for me, and I think it's big for a lot of researchers in accessibility, is the emergence of AR tools like ARKit and AR Core. ARKit came out in 2017. The amazing availability of visual inertial odometry, all this 3D geometry at your fingertips. It's really incredible. And I think a lot. Anyway, I'll stop there for now. I may have more to say about that, but I think that's been an incredible thing because it enables a sort of a spatial reasoning, 3D spatial reasoning that was really not there before.
Yeah, definitely. I think many of your points link quite nicely to Andrew and his work in kind of mobile focused deep learning models. There's all this extra all this extra stuff that comes with integrating other information from a mobile phone, and we should have deep learning models that can work on these mobile phones in order to use all that info. So Andrew, how about you? What have been in kind of deep learning on the edge, or I guess deep learning more generally, what have been the kind of key turning points you've seen over the last decade?
Yeah, let me maybe just work on deep learning in general to start. Both Marcus and James had some very nice answers, but I'll just very concretely say AlexNet. That was just the big turning point. It might sound obvious, but what was it? Right? It was proof of concept that feed-forward convolutional neural nets could work at high quality. And it brought together, again, the feed-forward convolutional net, larger scale data, and compute. And having those three kind of recipes together kind of set the stage for all of this. And I guess one other small neglected part is clever recipes on how to train it. Whether it's kind of, some of this is details, but these details are important. Whether it's kind of the distortions to kind of simulate large scale data, whether it's, small innovations like ReLU, like all these pieces all kind of came together in one package and said, hello world, deep nets are the way. And so going forward, the themes are around larger and larger models. So again, what we discussed, transformers showing their kind of universality, but they're very data hungry to have these kind of larger and larger, accuracies. Obviously, they're very compute hungry as well. So we haven't touched as much on the data side. Data is kind of the lifeblood of all this stuff. So I think some of the new results on self-supervised and semi-supervised is very important. I think federated learning is very important. That's a way to kind of keep data private while still training joint models. And then, we touched a little bit on it's important what the models are being trained on, in that, you want fairness. And so maybe one thing to really, really anchor on here is test data is super important. How do you know you're doing a good job unless you have a really representative test set? Mm-hmm. And so, the VizWiz challenge is maybe one example of, you have data that's representative of the task you want to solve. Because while academic benchmarks are nice, when we actually want to deploy these things for real at scale, and so that they work for everyone, we need that North Star of evaluation data to make sure that things work for real, and then the fairness part that they work for everyone.
Yeah, I think there's a great point, and I definitely agree on the AlexNet point. It really was the just the sort of coming together of so many things that then have really spurred on or initiated, catalyzed kind of the last decade of research in computer vision. But yeah, some other great points as well. All right, so we're almost nearing the end of the panel, and I thought to end off, it would be good to just get from each of you sort of 2 sentences or 2 points around, what does the next decade look like? What are the things that are going to be, what is the next frontier? What is the next big thing? Just kind of 2, high level 2 points around, or 2 sentences around what do you think is going to be the next big thing? So yeah, how's about we start with you, James?
One thing that may not be on people's radar is augmented reality as something that's especially useful for blind people, and it can be done largely in the audio domain. We don't need to wait for affordable, comfortable headsets.
Excellent. Yeah, I think there's been a lot of growing momentum around AR, VR, and a lot of exciting links there to how it can improve accessible technology. Great point. Andrew?
Yeah, I think there's something around basically the ubiquity of all of these things. The tasks that deep learning can solve are becoming just a component that you can plug in, similar to the AR kit, AR core that you mentioned. And then what's on the kind of cutting edge is what are the new capabilities we kind of bring online as we scale the size of these large language models, these large vision models, the multimodal models that Marcus is working on, and others. So basically, what will those new capabilities be as things get very, very big?
Mm-hmm. Yeah, nice. Agreed. And wrapping up with Marcus, what do you think is the next frontier, the next big thing?
I would say probably the general assistant, both assisting visually impaired users, but also assisting all other users. I think there will be, right now, at least my personal experience, they're still a bit awkward to use most of the assistants. They have lots of flaws. But I think we will probably get in maybe the next 10 years to a stage where they're so good that they become more and more like the smartphone. Like maybe before a smartphone was there, nobody was saying, at least I personally wasn't thinking, how could that be useful? I think we might get to a stage in 10 years where like an assistant, a visual assistant for visually impaired users, for a general assistant for everyone, might be so omnipresent eventually that we might not know how to live without it. Similar how we don't know how to live without a smartphone, or lots of us don't.
Yeah, great point. And I guess, that directly links to your work at this intersection, because of course an assistant like that will need to have, the ability to both visually reason, but also lingually reasons. So a nice, obvious place for your research, your current research. Great. Well, thank you all very much. We've sadly come up on time, so we'll have to wrap up our discussion here. But it's been really fantastic to have you all here today to learn more about the work that each of you are doing, and also to hear your perspectives on, how far computer vision research has come over the last decade or so, and also still how far it has to go. I hope that you've enjoyed participating in this discussion. Thanks again for joining us, and we'll say goodbye there. Thank you very much.
Thank you very much.
Thank you, Daniela, for organizing.
Thank you.
Next panel will begin shortly. 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 The show will begin in 1 minute. The show will begin in 30 seconds. The show is beginning.
Interdisciplinary Panel 1. A product developer, blind technology advocate, and computer vision researcher discuss the future of visual interpretation technologies. Moderator, Donna Gurari, Assistant Professor, University of Colorado Boulder. Speaker, Stephanie Inyart, Chief Public Policy and Research Officer, American Foundation for the Blind. Speaker, Karthik Kannan, Chief Technology Officer, Envision. Speaker, James Coughlin, Senior Scientist, the Smith Kettlewell Eye Research Institute.
Hello, and welcome to the fourth panel discussion of the VizWiz workshop, everyone. My name is Donna Gurari, and I'm an assistant professor at University of Colorado, Boulder, where I also lead the Image and Video Computing Research Group. I'm really excited to have three panelists with us today who can share very diverse experiences around the development of computer vision technologies to meet the interests and needs of people with vision impairments. First, we have James Coughlin to speak with us about the cutting edge of computer vision research. He is a senior scientist at the Smith Kettlewell Eye Research Institute, where he has worked since 1998. Over the years, he has served as a world leader in designing a wide array of impactful technologies for the blind and low vision community. We also have Karthik Kannan to discuss the development of industry products that use computer vision to assist people with vision impairments. Karthik is the co-founder and chief technology officer of Envision, a company that builds an app and smart glasses that uses AI to describe users' visual surroundings. Finally, we have with us Stephanie Inyart to share the perspectives of people with vision impairments based on her personal experience, as well as her professional role at the American Foundation of the Blind as the chief public policy and research officer. Welcome all. It is a pleasure to have you with us. And with introductions completed, I am excited to now dive into our panel discussion. To begin our conversation today, could you please share about what has surprised you the most about progress that has taken place over the past 10 to 20 years around technologies that provide visual assistance to real-world users? And Stephanie, would you mind kicking off this conversation?
Sure. I've been using assistive technology for visual disability since the 90s. And I think that I thought at this point in terms of the trajectory of where we would be, I thought that we might actually be a little bit closer to the ways that Apple as a company has kind of built in accessibility and on a broader scale. I thought that we wouldn't be in what I see as like a very responsive sort of culture where we have, advances and we're trying to figure out how to essentially make them accessible or how companies can kind of on the back end make them accessible. I also think that assistive technology, when we're talking about some of the actual tools that people are using, I thought that we would actually be at a spot where assistive technology would probably be released with a fewer bugs that do exist in the kind of technology that people are relying on day to day. So those are some of my thoughts.
Thank you, Stephanie. Karthik, could you share a bit about your perspectives?
Sure. From my perspective, I do see that like assistive technology. For me, it's I think maybe a slightly different perspective than Stephanie, in the sense that I think now there is a little bit more focus on assistive technology, or at least over the last 5 years since we started Envision, every year progressively has put assistive technology more in the spotlight. I think a lot of people now recognize, a lot of developers, a lot of engineers, because of the big push from some of these companies, are slowly starting to be able to become more aware of assistive tech. 5 years ago, when we first started Envision and we were trying to build an app that had complete was fully compatible with VoiceOver and dynamic type and some of the other assistive technology tools out there. There was little to no documentation that I, as a developer, could find that could get me started with assistive technology. I had to talk to a lot of users and a lot of trial and error, and basically all of the assistive tech documents were really in some backlog or backward part of Apple's documentation. I'm at least glad that 5 years later, they are starting to put that more front and center. When I look at the Google I/O that happened this year, I could see that assistive tech was slowly, was at least being spoken of. Accessibility was sort of packaged as one of the innovations in many of the different tools that folks like Google or Apple announced. It's definitely not where it should be. There are still 80% of the developers that I speak to have absolutely no clue of assistive technology or the fact that these tools exist. But but I'm hoping that as we start, building newer technologies like smart glasses, I'm hoping assistive technology is front and center versus, an afterthought that was the case with a lot of the newer technologies that have come before the current state of awareness there is. So for me, it's more that it has grown in the past 5 years only because I've been in the industry for the past 5 years, so I can see that delta of difference. But I think it's definitely at a place where people are becoming more aware.
Great. And James, would you mind sharing your thoughts?
Sure. Yeah, a number of sort of pleasant surprises. When the iPhone was first released in 2007, I sort of feared that it would be completely inaccessible with the touchscreen keyboard. And of course, we found out that Apple was putting accessibility in to the whole system. And it's in fact the preferred phone for most people with visual impairments. I think the statistics say that. So sort of, amplifying what Kartik said, I mean, accessibility, I think, used to be perceived as a sort of a niche thing, a sort of a niche value. And now it's universally recognized as important. And especially younger people today with visual impairments, they just have an expectation, oh, this software or system should be accessible. If it's not, why isn't it? How soon can we fix it? And I think that's just an amazing sort of progress over the last, 15 years or so. I've been amazed at seeing, apps like Seeing AI come out, a very, powerful app that's free to end users, allowing them to get a lot of visual information. And also one cultural point I want to make about that is that any AI-based system is going to have some error modes. It's going to, make some inferences that are not quite right, or maybe in some cases very wrong. And I think that I was concerned maybe 5 years before that kind of app was released. I was concerned that there'd be tremendous backlash when AI was sort of unleashed with warts and all. But I think people are understanding that this is it's amazing technology. You can't expect it to be perfect. You have to work with it. And then something that's maybe slightly lower tech, doesn't necessarily involve computer vision at all. The availability of sighted assistants like Be My Eyes or Ira. That's a great match of smartphones and connectivity to sighted assistants. And I think that's just a great thing. And of course, it doesn't have to be either human or AI. You can combine them. And that's probably the most sort of promising combination to have. So those are my surprises.
Thanks. And for our next question, I'd like each of you to address, what do you see as the current limiting factor or barriers in developing better visual interpretation technologies? And Kartik, if you could start us off.
Sure. I think The current limitation is the lack of representation in some of the more popular data sets that are used in the computer vision space. Like, for example, we have ImageNet, or, if you look at something like OCR, there is the COCO, data sets and all those things. Or if I'm looking at, say, training a model that recognizes documents, there are these other popular open data sets, but all of them represent how images would be taken or perceived, by a sighted person, right? For example, we recently built a document detection AI on the on our smart glasses, where it basically guides a user on how to move the document so that they can take an entire they can take a picture without having to second guess whether they're holding the document at the correct distance, or is the document fully in frame or not. And when we started looking at some of the more popular data sets in this problem space to see how it is, we came across very neatly taken pictures. The document was properly framed. It was at the center, and you could go ahead and build, or you can say that that particular data set was primarily collected by people who were sighted. Right. Whereas when we are trying to build visual interpretation technologies for people who are visually impaired, I think we need to have more data sets that have them taking images and making that part of the mainstream conversation in computer vision. Because someone who is visually impaired definitely is not going to take a properly center cropped image, with the document fully in frame. They're going to take it with different angles, and when we have those data sets available, I believe the research and the models that come out of that will be accessible, quote unquote, in a way, right? Because they're also trained on these type of documents. Microsoft is doing some interesting work with the Orbit data set, where they try to go ahead and ask visually impaired people to take pictures of the everyday items they use from their phone cameras and then upload them, and they made that data set open. But again, it's not a very well labeled popular data set. I mean, we've tried to work with it, and it's pretty difficult. And I wish, as accessibility takes more center stage, and as computer vision, people in the computer vision industry realize the impact that their work is having in this particular community, I wish data sets also become more inclusive.
Thank you. James, would you please go next?
Yeah, sort of following up on what I was saying before, any approach to interpreting an image that's fully automatic is going to have limitations. There, limited accuracy, maybe an inability to understand context or nuance, or maybe the domain of applicability is limited if the image is something that's just completely different from anything that was ever in the training set. And so I think that combining AI with humans in the loop is really the way to go. But once you have human in the loop, that does limit the scalability. Now you're talking about requiring people to spend time labeling images and so forth. So I think I think it's a solvable problem, but I think it goes beyond the realm of technology. And I would love to see maybe programs where human labor is paid for and subsidized, perhaps. I think it would be a wonderful opportunity for many people who want to work from the home and they have good internet, but maybe they can't leave the home. And this is, if you have, so let's say normal vision, that kind of labeling task could be great. And of course, companies like IRA have really elaborate training programs. So it's not just an informal, off the cuff labeling of an image. It's something that's very well informed. So I'd like to see more systematic efforts to recognize that human in the loop labor is costly, but it's also extremely valuable. And then just another high level point, there is increasing awareness that we need descriptions of images. But just as web accessibility is now required by law, maybe we need some sort of standards for image and video accessibility, because right now it's sort of seen as an optional thing by far too many people. So it has to become a right and not a privilege.
Stephanie, would you please share any thoughts you have?
Sure. I actually want to echo part of what Karthik was speaking to, in the sense that, I recognize I am one person with a visual disability, and I certainly, in my own experience, I couldn't represent the real true diversity that there is in the community of people who are blind and low vision. So from that standpoint, I really wanted to pick up on the thread that if you're trying to create something that is going to really, bring the most number of people along, I think that you have to have a real diverse sample in those that you're engaging with in focus groups and things like that. And I know that that's very challenging to do, because one of the hats that I wear at the American Foundation for the Blind is the research piece. And what I mean by diversity is not purely kind of racial and ethnic diversity, but age diversity, socioeconomic diversity, and including in that a real range in the amount of skill level that people have in using all kinds of technology, like even cell phones, to take things like pictures, and to really be able to get to an end product that's going to serve all of these different facets. I know that it's very easy to be able to do research that touches the blind and low vision community by kind of getting the same fairly well educated, fairly well tech trained group of blind and low vision individuals to essentially test products and give you feedback. But that is actually kind of like the educated tip of the iceberg when you're talking about the full range of people and ages and experience and tech training that exist in the community. So I really hope that that is also very much engaged as people are developing things.
Thank you. I would like to now shift gears and think a little bit about the future. So for our next question, could you please describe how you envision technology will work in 10 years for interpreting visual information for real-world users? And so as an example, what kind of skills will the technology have? And also, how might that technology deliver the information? So to start us off, James, would you mind going first?
Sure. I can imagine some sort of AI assistant that, is available on your smartphone, or your Alexa, whatever, which combines all sorts of sensors, of course, like any smartphone does, video, microphone, GPS, and it would be an interactive assistant, and you could ask it questions that might relate to visual information or audio or both. And so, for instance, maybe you could ask a question like, oh, is there a place I can sit down nearby? Maybe you're in a crowded place and there are a lot of people sitting, but you're looking for an open seat. And so, if you were to make such an app sort of today, it would maybe be standalone. And maybe there would be feedback to help you, move the camera, point the camera, make sure that you're covering the full range of view. But I'm hoping that in the future, in 10 years' time, wide angle cameras, if not omnidirectional cameras, would be, standard. Because the aiming problem for a person with visual impairment is a really big one. And I don't think it's a permanent problem, but I think better hardware will improve with that, will improve that. And, of course, the feedback I'm envisioning might be in audio form. That's especially useful for people with vision impairments. But also there could be an augmented reality approach, sort of like OrCam, where you point at a passage of text, and that text that you're reading, that you are pointing to, is being read aloud. So maybe you could gesture. If you're blind, you could, hold out your hand and say, should I be going that way or that way? And with whatever precision you want to point. If you have low vision, then maybe some sort of visual display. And we've seen this, in some of Google's products, where arrows are superimposed on the screen to guide you to a destination. Of course, in 10 years, maybe you'll be wearing some sort of, headset. I don't know. That's I'm going to be agnostic about that. But those are some of the things I'm picturing in 10 years.
Thank you. Stephanie, could you share your thoughts?
I mean, I guess, the process of being able to travel around and have a real sense of all of the details of a surrounding, we've begun to chip away at aspects of that, but I really would hope and foresee that would strengthen, so I have a complete, earbud in my ear, understanding of everything that's around me. I'm not calling on people to read me menus or anything like that in a dynamic environment where, lighting can be an issue or any number of other things. So I would hope that all of those problems, so to speak, are worked through. Something that I think is kind of interesting, and it's possibly because of the life phase that I'm in where I have young children, I think that the ability to read and make sense of very messy handwriting is something that shouldn't be overseen as something to tackle. You have things like messy handwriters, from doctors and things like that. Handwriting will still continue to be a thing. And so it's part of the technology space that hasn't really been fully addressed. And, so far, that's an area where being able to really, have a computer be able to scan it and truly track it with a lot of accuracy, there is still a lot of room to be done. And I'm thinking about this because I have literally a 5-year-old. So her handwriting is atrocious. I say that with happiness that she's writing, but to be able to make sense of it is still, there's still work to be done. I also think in the autonomous vehicle space, whatever can be done to shore this sort of technology up to kind of ensure that there is a capability in the autonomous vehicle space for people who are blind and low vision. That's a factor. And so I'm wondering where there may be innovations that may have synergy in this space and in fully autonomous vehicle operation, so to speak.
Thank you. And Kartik, would you mind sharing a bit about your thoughts of the future of technology?
Sure. I think, I might be biased because, smart glasses is the world that I inhabit day in and day out. And I definitely truly believe that we would be, moving to that era where smart glasses tend to become very prevalent. And maybe they work in conjunction with phones. Maybe they eventually become standalone, because we see that, the whole messy feeling of having to have a phone in one hand, a cane or a guide dog in the other hand, and pointing that. We already see that with the 1,000-odd Envision glasses users, that is largely, a problem that needs to be eliminated. I think in terms of the AI, I really believe we probably would have at some point like an NLP plus computer vision, multimodal kind of a AI, which you can converse with. Like, I probably would call it like a visual assistant, very similar to like a voice assistant that Siri is today. And like what, James was also talking about, being able to query things about your natural surroundings. I think it also would be very context aware. Like, for example, right now today, if someone wants to, like, even with something as high tech as the Envision glass, someone wants to read a document, they need to explicitly say, I want to read a document with the glasses. But I'm hoping that, you just point, there is an always on camera, for better or for worse, that does become more context aware. As you just point stuff at it, it's able to interpret it. I think lastly, I also envision a future where AI is highly personalized. I think it learns more either, so now we already have a lot of, things like model personalization, and all these things are starting to slowly take off. Plus we are also, I hope that these models become personalized in a more privacy, first way. So, when there are areas that I am really excited about, stuff like federated learning, that I wish become more mainstream. And I wish, those are the kind of technologies that eventually become the gold standard for personalizing AI. And lastly, I do want to see more inclusion in the data sets that become mainstream in the computer vision community. I do want to see, an image net, but then probably an image net that also includes images taken by people with a visual impairment. And we try to build data sets that are accessibility first, in a sense, and rather than, trying to always look at images from the perspective of someone who's sighted, even though these technologies, might be deployed only for people with, sight, for example. We do want to at least have some of these large open data sets slowly start to address, the accessibility problem as well, right? I mean, for example, even if a company like Envision today wants to build a model that, for example, recognizes a white cane or a braille display, we do have to collect all of that data by ourselves. Even if we want to use an open data set just to benchmark some models, we still have to do a lot of that work ourselves. And I think that might also discourage startups from, like us who don't have a lot of resources from pursuing difficult problems in the accessibility space. So these are the 4 things that I really look forward to. And I definitely think with, I would love to live in a wearable world where, like a visually impaired person could just wear stuff that every one of us are wearing and is able to do things in a more hands-free and obtrusive way.
Great. I actually want to do a follow-up question on some of what Kartik was mentioning with personalization and context-aware technology. And in particular, one of the challenges I've had, and I've seen other people have in trying to design computer vision models for people with vision impairments, is trying to decide what information to include in visual interpretations. So as an example, if a blind person shares a picture of their shirt, there's a question of, should you describe the shirt, like saying it's red with some pocket and bows, or should you instead say it's dirty versus clean? And then, there's another example, which is more controversial, which is when describing people, should we be ascribing gender, race, or attributes about people's relative weight? So I'd love to hear your thoughts about how you think we should decide what information to include in a visual description. And so to start us off, Stephanie, would you mind sharing your thoughts?
Sure. And I think what I may have to say, it might be a little bit controversial in the COVID-19 era where we do have a lot of kind of visual descriptions as we hop onto Zoom calls and, congregate in spaces. I actually think that the kind of content that people begin to share about what their personal visual description isn't even the most helpful for me as someone who has a visual disability. So where people are commenting and letting me know, like what their haircut is like, or potentially if they're middle-aged, or what their shirt looks like, or potentially what's going on in the background, that they're in a home office versus elsewhere. I mean, I don't feel like that adds much value to my experience. It's true that visually, I don't have enough vision to be able to take in those sorts of nuggets of information on my own. And I am acclimated to that. I think that some of the most important content that we need to know is actually things that people have to literally volunteer themselves. So for example, the pronouns that people prefer, it's never something that computer vision would actually know. Because people may identify a certain way and, select or prefer pronouns that there is a distinction or a not easy connection between. And so I don't know if these kinds of descriptions are the kinds of descriptions that are the most useful for the blind community. I know I'm not alone, but at the same time, I think that some people have now migrated to really, truly enjoying this kind of content. I think that if there's a way to select the kinds of characteristics that are most important to you, that it might be a personal selection sort of endeavor, and that might be most useful, because I think from an organic perspective, that's really where I want things related to someone's maybe racial or ethnic identity or their age. If it's relevant, it's going to come up organically. And I kind of like that I can't necessarily visually take that in and I'm not searching for it. But where we actually have things that will make a legitimate distinction for people if we use the improper pronoun, those things always have to be volunteered. And so, or identified. And so I want to leave it there, because I think that there is some tailoring that needs to be done so people like me aren't flooded with a lot of detail around this that I think is really irrelevant and is meant to be sensitive to my needs.
Thank you. Kartik, would you mind sharing your thoughts about how we should decide what to include in a visual description?
I think it's primarily about asking the users. I mean, I'm coming purely from a product development, startup mentality that's building tools for people with a visual impairment. I think it's often about asking things that matter to them when we're trying to solve a problem. And it's also about, meeting that expectation with technology and trying to manage expectations as well as to what the technology can do. A simple example is, on the glasses, we just launched a feature that helps people to be able to recognize tables in a document, right? So it detects tables, it, speaks out the content of the table for them. Now, when we started to sit down with the users and ask them like, okay, what do you want us to do? Their expectations were really high. They were like, yeah, I want to know exactly what the heading in the table is. And, I want to know if, I want to be able to interpret the table exactly like how like a sighted person would do. But unfortunately, that technology isn't there yet. Unless I spend a lot of time semantically understanding the context of a table, sometimes, headings in a table might not always be bold, right? It might just be like the same font style as the other things in the table. So how do you, just visually looking at a table, there's no way for you to interpret the heading in a table, what the heading in a particular column is, right? So that is a place where we'll have to tone down the expectations, saying, hey, the technology can't do that yet, but what we can do is try to give you the best possible interpretation of a table in a document, right? And people are oftentimes okay with that because they know that's just how far the technology can go as of today. So I've always seen that, we need to constantly keep talking to the users, to be able to understand what their needs are. And then us as technology folks need to know if we can actually meet those expectations. If not, how do we manage those expectations? And that's where design plays a huge role, because design can really, pad out some of the areas where technology cannot really go ahead and move things, right? So we've always observed that it's like a three-way, sort of conversation between the users, the technologists, and the designers, and then trying to constantly co-create the, ideas, and always asking for, whenever in doubt, we don't assume, we just ask, people in the community what they would want out of a particular problem, and then try to solve that.
Great. James, could you go ahead and finish us off with this question about what to include in visual descriptions?
Sure. Yeah, I want to sort of echo what Stephanie was saying about the need to tailor the information to the particular needs of the person who wants it. And, there are many different kinds of visual interpretations that you might want. I mean, for instance, audio description for a movie is going to need to record a lot of sort of quote unquote factually irrelevant details, but details that are maybe important to the plot line or to the development of a character, and as opposed to, as Karthik was saying, if you have a document and there's a table in it, you kind of just want to have the ability to report all the all the numbers in the table and where they occur and all that. And I think it's just helpful to think about the range of different needs. You might be, and Stephanie mentioned different maybe settings, to tailor what you need. You might be in a hurry and you want just the basic information, or you might want to review it a second time and get additional details. You can imagine some people, maybe children, need simpler vocabulary in describing things. Or, maybe if you're using a screen reader, you might want a more detailed description than someone who's just, listening to audio description of a movie. And, the other thing is that the mainstream kind of application, I think, is also kind of interesting. Situational disability, if you want to call it that. Oh, I have normal vision, but I'm outdoors. It's really sunny. I can't really watch this video too well. I can't really see what's going on. Oh, let me turn on this description feature. That could be great. And, I would just note that, 15 years ago, I don't think a lot of people with normal hearing used captioning, but now lots of people, I do this too, turn on captions just to reinforce, what is seen. And so maybe there'll be mainstream interests as well. So we don't necessarily have to predict all the different needs, but we have to be open to all these different needs. And just the last point I would say is that, we often think of the description as if it's some definitive description of an image or a video, but of course there are many different forms, and maybe an interactive interface is the best in many cases. So you query, maybe you get some very basic information at the get-go, but then you ask specific questions, rather than the technology assuming too much about what you want to know and what you don't want to know.
Thank you. I would like to dive into one more detail that we have already talked about in this panel discussion, which is the development of data sets that represent people with vision impairments. This is a critical underpinning to developing computer vision technology and more generally AI, right? And so I was hoping to hear what are your expectations about how such data sets can be built responsibly, and also about any experience you have in building such data sets. And so Kartik, I know you've already been talking about this quite a bit, so if you could please start this conversation for us.
Yeah, I think it's about whoever's building such a data set to first like truly understand the problems that they're trying to solve with this data set. For example, if it's a data set that's going to contain images of documents that are that could be trained on a document detection AI at some point. To give an example of how we went about it, I think what we first did was like really understand how the users who are going to be using the model would actually be taking images themselves. And I think that was a fact-finding mission that we went on. Like, okay, if someone's wearing, smart glasses, how will they actually go ahead and hold a document? What kind of angles do they, hold the document in, and so on and so forth. So it's first really understanding the data from a user point of view. And then from that point on, what we did was, we have almost like 1,000 people who are currently using the glasses across the world. So we, went and enlisted volunteers. So we said, hey, listen, we're trying to build this document detection AI, and there is actually no data set that's out there. We went ahead and took about 2,000 images ourselves using the glasses, and did and put it through the process of augmenting it and so on. If you guys want to go ahead and share your data with us to be able to build this model, that would already be like a great start for us, because then we can see how things are from your perspective. So we involved the users in that. I think they really liked it because they felt they had a say in how the data set was built, and that helped us really build a tight feedback loop. And as the data was coming in, we could see, for example, how this is to again touch on James's point of like personalization or different people having different needs. We saw people with low vision take different types of images with than people with no vision, for example, right? So again, it's important we realized it was important to even have diversity in the kind of data that we could collect for with people with different visual impairments, right? So we had to go ahead and we had to ensure that even though our users might have low vision, or some users might have no vision, we didn't really make the data set, like we didn't imbalance the data set by having just images from like people with one types of visual impairment. So that also needs to be taken care of, that you understand the problem space more deeply, that okay, there are different people who have different visual impairments, so the people you pick to collect the data set also matters a lot, because that is how that's basically what the final AI is going to also be able to do. So for us, it was understanding the users, like the exact problems that they're going to, like the AI is going to solve, to involving them, and 3, trying to really ensure that there is enough diversity in the data set, so that we don't always go ahead and only pick one group of people to build this data set with. And I think that helped us a lot in building a very inclusive document detection data set. And we eventually ended up with tens of thousands of images, and we built an AI that could work in most lighting conditions and so on and so forth. But yes, it was months of effort to build that data set for us eventually, and I hope at some point we could be able to open that data set for other researchers to also use once we add to it over the years.
I would be super excited to use that data set when it becomes available. James, would you mind sharing your thoughts about how to build data sets responsibly, and any experience you have in building such data sets?
Yeah, I mean, I think at a high level, it's just important to remember that the data set is just part of the entire sort of process. You're trying to address some kind of need, and you're thinking about a particular population. I mean, you might aspire to helping everyone with a vision impairment, but in many cases that's not realistic. If you're relying on someone to be holding a camera, like a smartphone camera, for instance, you might not be able to get that to work with people who have hand tremors, for instance. There are many cases like that, and so I think it's important to think to be clear on what problems are you solving, to make sure these problems are grounded in the actual needs of the people that you're trying to address in this data set. And also Kartik mentioned a feedback loop, and I've seen feedback loops in the data acquisition process along the lines of, okay, for instance, we're acquiring images for indoor navigation, and one of the early decisions that we made was, well, there's no reason not to give the user of this this indoor navigation app that we're developing, there's no reason not to give feedback to the user to help the user aim the camera roughly horizontal. There's not a lot of utility from a computer vision point of view if the camera is aimed toward the ground, or if it's aimed toward the lights. That's usually a bad use of imagery. And of course, for some people, it's very clear how to hold the camera roughly horizontal. Other people, that's not always so clear. It's not always so obvious. So giving feedback before you even acquire those images actually turned out to make a lot of sense. And then, of course, there's a question of, well, what exact form? So you want to iterate, and for something related in this indoor navigation app that we're developing, we offered feedback that, like, the very first participant said, "Oh, this feedback is so horribly annoying. I just can't work with it," and we changed it. So there's going to be a feedback loop until you get some kind of reasonable acquisition process. So there are conditions. What are the exclusion and inclusion criteria of the people who are taking this data? What are the tasks that you're having them do? In the indoor navigation setting, we've done different types of tasks, such as, I'll give you verbal directions, walk straight, turn left, that kind of thing, and you hold the camera straight ahead while you're walking. In other cases, we ask the person, just walk, explore the floor of this building as much as you can, and we'll give you, some time to do that. We'll make sure you're safe. We're not going to abandon you. And you have to look, well, are you going to get different kinds of images, based on that? So anyway, those are the sorts of things I think about in sort of making the data set acquisition, responsible process.
Thank you. And Stephanie, would you mind sharing your thoughts about how such data sets can be built responsibly?
I think it really has to do with age diversity and diversity of the types of visual disabilities, visual acuity that people have, because, that comment about someone finding the level of description or the type of description annoying probably closely ties to the level of vision that they have, the type of visual needs that they don't have met, and trying to kind of synergize with getting them the information that is a little bit out of their reach versus something that they already have access to or isn't as relevant to them. So, someone who has central vision loss may have a fairly good understanding of kind of the landscape view of things, but they can't read the fine print on something. And so they're not necessarily looking for this elaborate description. So I think you really need to zero in on, that type of vision loss that people have, as well as in terms of age is part of it related to how people actually have orientation and training and understanding of using technologies like this. So if you're including someone who's a 15-year-old in your data set and somebody who has age-related macular degeneration, you're probably, even if they have very similar levels of visual disability, you're going to have a very different kind of feedback loop from them. And so it really does need to encapsulate the fact that people enter and are part of the visual disability community at very different ages with very different levels of experience. So I know that it's really easy to be able to get people that have a high level of technical understanding to be able to participate in these sorts of endeavors. And it's harder to get people that are across the age span with varying levels of visual disability, varying levels of technology usage.
Thank you. So for our final question, this is basically putting a bow on the fact that we are trying to help facilitate the creation of an interdisciplinary community between users of visual assistance technology, the developers, as well as the researchers. And so I would love it if each of you could just share a little bit about any conversations or collaborations you already are having across these different disciplines. So talking with different domain experts and sharing a little bit about what you find works well versus what does not work well in those collaborations or conversations. And so to start us off, James, would you please share about your thoughts?
Sure. My background is in computer vision, sort of a physics, computer science, engineering view of the world. And so early on at Smith Cadwell, I was told, don't fall into the engineering trap that so many people do, which is just falling in love with technology and solutions. Think about real problems. Make sure you're not solving a problem that actually is not that important. And so I just like to tell that to everyone I meet who's thinking about getting involved in accessibility, because the technology is undeniably cool, and a lot of people feel that way, but that shouldn't prevent you from having conversations with the people that whose needs you want to serve. And so I'm working on a few projects. One project with a blind colleague, Brandon Biggs, to make a 3D playground map totally accessible to playground visitors. And so the idea is, you're going to a playground. In fact, this is a playground that was sort of designed from the get-go to be very inclusive. But Brandon found when he was visiting a playground some years ago, well, maybe not as inclusive as it could be for people with visual impairments. There are a lot of fun structures, but how do you figure out what's there? You can go up to a structure and the function is not necessarily obvious right away just from feeling it, because it's not just swings and slides. There are a lot of other different things. And so his idea was, well, let's have a 3D map, and let's have audio labels so that when you touch different parts of this map, you hear a name and perhaps a description of what this thing is for. And so this is an example of a project that was originated by a colleague of mine who was blind. And so I thought it was really exciting to do a project in that way, as opposed to just saying, okay, well, I think this might be a good project. A colleague of mine at Smith Cadwell is working on audio description, and she's working with a lot of people who are sighted who want to learn to do audio description, and they have to learn to, sort of like we were talking in the earlier question, find the content that's most appropriate to put into a video, and also to get feedback from actual end users. So I think a lot of people go into this process thinking, oh, I have a good idea of what description should be, but you need to get sort of ongoing feedback from your end users to understand, well, is this working? How can I improve my audio description? And some surprises along the way. I think initially my colleague, whose name is Charity Pitcher Cooper, initially I think she had the feeling that audio description maybe should be prioritized for factual videos, informative videos, or educational videos. And that's certainly a very important thing. But she also came to realize by working with people in the community that there's a lot of need for sharing videos that everyone else is sharing in the sighted community. And so if that means sharing, a silly kitten video that may sound frivolous, but it's an important thing to a lot of people with vision impairment to be able to share whatever video they want with audio description. So, I think she may have had some ideas about what videos would be prioritized, but, she's learning different things. And then just a high level note, when I began my research at Smith Cadwell, I would talk to small numbers of individuals with vision impairments, and that was very helpful. Learning about actual needs and doing usability tests, and you have to constantly iterate these things. But then at some point I realized it's also extremely helpful to talk to vision professionals. You talk to one teacher of the visually impaired at a TVI or an orientation instructor, and some of these people have been working for years, and they have the perspective of dozens or maybe even more people with vision impairments. So whereas, if you talk to, the saying is you talk to one blind person, you've spoken to one blind person and gotten their opinions. If you talk to a TVI or an O&M, very often you're going to get just a wealth of information. And so I think starting out, that it would have been helpful for me to know a bit more about that as an additional resource.
Thank you. Stephanie, could you share any thoughts about what works well versus what does not work well in collaborations and conversations?
I mean, I think that concept that you should try to look at it from all these different touch points and looking at those that are working in the, we call it the personnel prep field, those that are orientation and mobility specialists or TVIs, it gives you this wealth of information. And I know I said earlier, I represent really only myself in my own experience, and there are so many other experiences in the community to make sure that you're tracking and you're kind of, building for, because there is such a wide array of needs, experiences, et cetera. American Foundation for the Blind, we interface in so many different kinds of touch points with people in the corporate or the research space, whether we're, doing consulting work that's supporting accessibility issues that companies are facing, or we're looking at the nitty-gritty details of what standards and, guidelines should exist and what that floor should be in terms of the floor of expectation and rights. We also speak with them about whether or not they're in a spot that they support advances of certain types related to the policy realm, where a lot of these details get worked out. And often it's a little bit complicated for different corporate organizations to figure out where they sit in that civil rights context of what people kind of have a right to. We talk with them about research of our own, which is more on the social and emotional aspects of the visual experience. And I think that the fact that we talk with them about all of these different things and all of these different touch points, it kind of, I'm hoping that it helps them understand that it's not purely about one thing in our community, that there's a dynamic interface here related to the way technology can enhance people's lives. And so we have a variety of conversations on various topics, but I do think that there is a knowledge gap in thinking about this as a very, very dynamic area from kind of a rights space and also from like a user space. And so, we traverse that landscape.
Thank you. And Kartik, any final words from you on how to establish effective collaborations?
Sure. I think if you are building products for people with a visual impairment, and if you're not visually impaired yourself, I think the first thing is acknowledging that you are not the user. And so you have to be building products or literally co-creating products with the users always. And this is a cliche at this point in the whole product development world, that you have to talk to users. In other areas, or when you're building other types of products, maybe you could make some assumptions, but we've always realized that we cannot make assumptions about any of the things that we are building, and we always need to ask people. It also helps that, yes, we do have people with a visual impairment in the Envision team who are part of the whole product development process. They're not customer support people or stuff like that. They're actually part of the whole product development process. They're designers who are, constantly using the product for like day in and day out. And that already gives us a lot of ideas on collaborations. So what we have noticed works best is, when we want to first, work on a new product or a new feature, it's always best to show people rather than tell people as to like what, we are building and this is the thing. So what we usually do is we build early prototypes of the features that we want to build, invite a lot of users. I think this was pre-pandemic, but yeah, like even during the pandemic, we used to do this online, which wasn't great. But once things started opening up in the Netherlands, we started inviting people back again to the office and just, gave them prototypes after prototypes and for them to try it out and for them to build and give feedback on the fly. One of my favorite moments innovations that happened this year was when we built this whole document detection AI. We literally had a computer vision engineer open the laptop, connecting the glasses to his, to his machine, and just having users try out different versions of the model that we built. So we weren't really sure whether users are going to want better, like faster models, or would they want more accurate models. And we didn't know where that sweet spot was, right? How many frames per second should we be able to process before it becomes too slow or too fast, right? That kind of assumption we cannot make ourselves. So we invited the users, gave them like 5 different glasses running 5 different types of models, and had them do that. And we also, in a way, picked users I really like Stephanie's idea of like picking people from completely diverse backgrounds, age, right from different age groups to people who have different levels of tech savviness, to people with different levels of visual impairment, right? So we had these 3 buckets. We picked people who were like 89, 85-year-old people whose house we went to, and we gave them prototypes of the glasses and saw how they were holding the document. And that was totally different from a 20-year-old college student who's completely visually impaired and has lived in the world of screen readers and Siri right from the day he was born, right? And so it's just being humble enough to understand that you're not the user. So you should go all the way to be able to get the feature right or get the product right? And I think that's something that it's accessibility, I believe, is still a very human intensive space. You have to interact with humans. You can't be this you can't sit on this developer high ivory tower and say, okay, I'm going to build something and then I'm going to expect it to be accessible. You need to talk. And I think what most people outside this industry don't realize is how welcoming this community is. When we first launched the Envision app and the Envision glasses in like 2017 and 2019, the first place I went to was Apple Viz, which is this really popular forum for Apple users, and just put a note out there saying, hey, we're building this thing and, we'd love to get some feedback. And the next day I woke up to 500 people wanting to sign up for a beta and then give us feedback, right? I think that's something people don't realize when they start to work on accessibility, is that people in this community, in the accessibility community and disability community in general, they really would like to share their, make themselves heard. And I think if you listen to them and you understand and be humble enough to accept that you're not the user and you should work with people, it becomes so much more easier to build accessible products, right? I wish all companies and all developers would do that, right? It's as simple as that.
Well, thank you. We are now at time, so I just want to thank each of the panelists. This has been a fantastic conversation, so thank you for making the time.
Thank you so much for having us.
Thank you very much.
Next panel will begin shortly. Next panel will begin shortly. next panel will begin shortly. The show will begin in 1 minute. The show will begin in 30 seconds. The show is beginning.
Interdisciplinary Panel 2, a product developer, blind technology advocate, and computer vision researcher discuss the future of visual interpretation technologies. Moderator, Ed Kutrell, Senior Principal Research Manager, Microsoft. Speaker, Will Bettler, Chief Experience Officer, Be My Eyes. Speaker, Andrew Howard, Senior Staff Software Engineer, Google Research. Speaker, Daniel Kish, President, World Access for the Blind.
So hello, and welcome to another panel discussion of the VizWiz workshop. My name is Ed Kutrell, and I am a Senior Principal Research Manager at Microsoft Research, where I lead the MSR Ability Team. It's a group of researchers focused on innovating new technologies for people with a range of disabilities. Today's panel will be another multidisciplinary panel, where we bring together people from a diverse set of backgrounds to discuss the use and development of computer vision technologies to meet the interests and needs of people with vision impairments. So on the panel today, we have three amazing people. First, we have Daniel Kish, the president of World Access for the Blind, who has long served as an advocate for the development of new technologies that support the independence of blind people. He's the first totally blind person to be a legally certified orientation and mobility specialist, and is a world leader in perceptual navigation and echolocation, using vocal clicks and echoes to identify his surroundings and to navigate through them. Next, I'd like to welcome Andrew Howard. Andrew is a senior staff software engineer at Google Research with a PhD in computer science from Columbia University. Andrew is probably most well known for his work in mobile-friendly deep learning models, starting with MobileNets, then continuing through V2 and then MobileNets V3, and also MNASNets. His work has been broadly adopted in deep learning packages like PyTorch and TensorFlow, as well as across a host of mobile phone platforms and apps. And finally, we have Will Bettler, who's the Chief Experience Officer at Be My Eyes, a free app with an enormous online community that supports visually impaired individuals to get free, on-demand, live video support from around 4 million volunteers and companies. These remote visual assistants help users interpret their visual surroundings and overcome accessibility barriers. Will has also written numerous motivational articles about his journey with vision impairments and hosted 2 podcasts on the topic of vision loss and accessibilities. So welcome all. It's a real pleasure to have you with us. So with introductions completed, I'm excited to now dive into our panel discussion. So we're going to start with the first question here. So to begin our conversation today, I'm wondering if you could each share What has surprised you the most about progress that's taken place over the past 10 to 20 years around technologies that provide visual assistance to real-world users? So would you mind kicking this off, Will?
Sure. Thanks, Ed. Thanks so much for having us. I mean, hindsight 2020 or whatever people say. It's in some respects we've come so far. Like we used to have, as blind people, we used to have to pay hundreds, if not thousands of dollars for software that would recognize text on a page, right? And more or less, if you have access to a smartphone, that OCR is completely free now. On the other hand, so I guess I'm surprised to the extent to which mainstream tech has embraced these sort of assistive tools, and heartened by that. On the other hand, we don't have a lot of great data floating around out there yet about what the real world challenges are for blind and low vision people. What are the experiences, the barriers, the brands that are designing things that slow us down in our daily lives and prevent us from having an equal experience? So that is also a little bit of a surprise. And you'd think we'd have a little bit of better grasp on the state of accessibility in the world right now.
Great. All right, let's move along then. How about you, Andrew? What do you think?
Sure. So I'm coming a little more from a tech background, so I can give some color on that. But I really like what you said there, Will, in terms of really understanding how this technology can kind of be useful and really study how can it be most beneficial. From the tech side, I mean, what was very surprising to me was when basically deep learning kind of was the breakthrough technology. And, I got very excited to be involved in that. And, it just kind of keeps getting better and better. And, year over year, another task is basically being solved at a superhuman level. It's just kind of fascinating. So some of the actual applications of it, and again, my expertise is a little more on efficient computer vision, is at Google, we have a couple of apps that people have worked on, one called Lookout to kind of help folks, maybe navigate the world, understand the objects around them, things like that. And, that uses a combination of on-device and maybe server-side models to really assist folks. Then we had another really nice kind of demo app called Guideline, which essentially assisted blind runners to run alone following a line. Obviously, there's a lot of caveats around that, but that was really inspiring. And I was really impressed that it worked, although I shouldn't be, given that this technology just kind of keeps going. So, maybe those would be kind of the two big things. Wow, deep learning is solving so many things. And now it's about how do we find the tasks that we need to solve that we can then apply to deep learning. And, obviously this group is a great group to be working with for things like that.
Thanks, Andrew. Daniel.
Two main things. One is the cost of blind-specific hardware has, by and large, remained really, really high. The very first Braille display that came out in the early 1980s, late 70s, the VersaBraille system from Telesensory Systems ran about $8,000. It was a tape drive. It was a 20-cell display. It had 1 kilobyte of working memory. And now the note takers are $5,000, so they really haven't dropped in price very much. The other is the length of time that it has taken to really begin to embrace navigational technologies, depending on how you define that. It's only been in the last few years that GPS has become relatively easy to use, relatively blind friendly, relatively intuitive. There aren't really technologies out there that are convincing in the areas of facilitating navigation of the symbolic environment, the physical environment, and the social environment. So for whatever reason, AI or heuristics just seems to be having some difficulty, or it's people designing the technologies really seem to be having a difficult time assessing and addressing what the most pertinent navigational issues are and being able to address them.
That's great. In fact, that leads us into the next question, I think, here. So I want to start with Andrew. And the question here is, what do you see as the current limiting factor or barriers in developing better visual interpretation technologies?
Okay, that's probably a pretty meaty topic. I'll start maybe by leaning into more on my background. If I imagine a system that would, help folks navigate the world, this seems like something that you would want in some ways always on or on a lot through the day. And so then that's just kind of power limitations. And so, all of our kind of, heavy duty AI models, they're pretty power hungry. A lot of my work is about how to reduce that. So that's definitely one part of the recipe. Obviously that's leaning more into my background. But what I'm definitely hearing from both Daniel and Will is really understanding what the actual things that need to be solved. What are the actual kind of, to use the phrase, killer app, but what are the use cases that would be most important to solve? That's always the most important thing for any project to like nail down.
Absolutely. How about you, Daniel? What do you see as the current limiting factor barriers in developing better visual interpretation tech?
I think part of it is understanding what information is useful, also providing a relatively transparent interface for the user to quickly and efficiently filter information according to need, according to activity, according to circumstances. That's part of it. I think there are a lot. I think providing a hardware form factor, a hardware that's comfortable for people to use. I think training is huge. So it's one thing to come out with the all-powerful widget. It's another thing to actually get people to the point where they can effectively, safely use that widget. I mean, those are some of the.
That's great.
Those are some of the barriers
really
as I see
cool.
them.
So, how about you, Will? Coming from your perspective.
We're at an interesting intersection because when you look at something like Lookout that Google's developed or Seeing AI from Microsoft, you have these wonderful AI solutions for sight. And then on the other side of the spectrum with Be My Eyes, what we do is entirely a human solution. We use entirely crowdsourced human sight. And I don't think any of us on my team or those other teams would argue that one of those is going to solve all use cases. And so I think we need to find a hybrid, human in the loop, human assisted learning models that are really effective. And then going back to this idea of scaling it up, basing the learning on inclusive data sets as opposed to ones that are more contrived. And I think also I'd put in a bid there for that magical wearable that people can not only wear throughout the day without being, socially ostracized, but also that they can afford. We're on like an endless quest at Be My Eyes to find the perfect wearable that's not only accessible from a design perspective, but financially accessible to Daniel's point, because we're kind of gone are the days where we think putting expensive prohibitively expensive assistive technology on the market is acceptable. So those are some of the things we think about on a daily basis.
Oh, that's fantastic. And that actually leads directly into the next question, which actually I was going to ask you to maybe expand on, Will, is that I'm wondering if you can think, okay, so those are the barriers that are developing the visual interpretation technologies. But then the next question is, how do you envision technology will work in 10 years for interpreting visual information for real world users? And what kinds of skills will the technology have? And also, and I think specifically, feeding back to what you were just talking about, how do you think that technology is going to deliver that information? Is it live video, augmented reality, some other kind of crazy cool thing? What do you think?
I think from our perspective, like I said this in another panel, actually, we would love to send all of our 4 million volunteers an email tomorrow saying, we don't need you anymore. We figured out all the tech, right? But I don't see that happening anytime soon. And they can be a great, force for helping us develop that tech as well. So in 10 years, I think that our AI is going to help us. It's going to help connect us with the people that we want to connect with most. For instance, we offer specialized help in the Be My Eyes app. We can connect you to an expert at Google or Microsoft, but a lot of our users don't even know necessarily that service is available. The awareness is low. So if your tech can even do something as simple as recognize some logos, recognize like we were saying earlier, the task at hand, and say, hey, we can connect you with an expert, facilitate that deeper human connection. I think that would be a boon. I think it's never the flying cars or the whatever the thing is that we imagine, but I think it can be more subtle. And again, going back to this sort of like thinking in terms of like how can it facilitate the best possible hybrid experience is what we're really interested in.
Oh, that's great. Let's ask Daniel the same question. What do you think in 10 years the technology is going to be, and what will it do?
I think that we'll crack access to the symbolic environment. So we'll have developed a relatively seamless way of reviewing public signage, public markups, labels, things like that. We're not there. It's still quite awkward, but I think we will be there. I think access to the social and physical environments will remain harder. It's hard for me to predict where that will be in 10 years. 20 years, yeah, I think is more likely, but maybe not 10. I think that GPS GPS and dead reckoning solutions may improve as well. So certain kinds of route planning, certain kinds of access to mapping technologies. I think those things will improve markedly. But I think the parsing and helping an AI to understand the nuances of the social environment, whereas many people struggle with that, and the physical environment. Yeah, that's more of a question mark for me.
I want to just push on that a little bit and say, well, what do you think from a hardware perspective? Like, do you imagine these will be always on wearables? Do you imagine that you'll keep a puck in your pocket like you have the phone now, or?
It will be wearable. There was another piece I wanted to say is I think that learning platforms will improve dramatically. So I think that there will be many more opportunities for virtual learning, self-guided learning, DIY learning. I think the institutions of teaching blind people have not really come through with the most efficient and impactful solutions. So I think that the technology is moving in the direction of virtual systems, which are more likely to be, let's just say, desk-based or tabletop-based. But when you get into navigational solutions, they pretty much have to be wearable, or there's no point.
Oh, that's great. So, Andrew, as the technologist here on the panel, like, what do you see as to where technology is going to be in 10 years, and how do you think it's going to be delivered?
Yeah, certainly 10 years is a long time frame. Obviously short on human history, but really long from technology perspective. I think we definitely see a theme around AR becoming more of a thing. So, I can imagine technology knowing more about you and your context, but also keeping that kind of private to you, not really a shared context. And so then you and your technology can kind of interact in a more seamless way. So one of the kind of aspects that's relevant for both maybe this community, but even more broadly, is as you're interacting with your technology, you'd like it to enhance your abilities. You'd like it to bring your attention to the information that you need when you need it, and not kind of needlessly kind of spam you with different things. So to really accomplish that, it seems like you will need a kind of good understanding of the context and the user. And obviously that deep, some of that user context, obviously you'd want to keep that very kind of private within the device. That's a really important theme. And so what might these devices look like? Certainly we can see the trajectory of kind of wearable augmented reality types of things. The cell phone form factor, the mobile phone, 10 years, that kind of feels like that might be antiquated. So I guess those would be some of the thoughts.
Fantastic. Thank you. All right. I want to dive a bit into the specifics of how to decide what information to include in visual interpretations. I mean, this is all associated with the CVPR and computer vision. And I know we've struggled a lot with this on my team, and I've heard the same thing from colleagues. So I want to start with Daniel. And the question here is, like, for instance, if a blind person shares a picture of their shirt, should one describe the shirt's appearance, such as its colors and logos, or should one indicate whether the shirt's dirty? Or, as another example, it can often be controversial on how to describe people. Should we try to ascribe gender, race, attributes about people's relative weight, height, etc.? And I'm wondering if you could discuss a little bit about how you think we should decide what information to include when we provide a visual description. Daniel?
That's a meaty topic because it is going to vary so much from situation to situation, activity to activity, environment to environment, and person to person. I, for example, have no desire for what I will call the social cue information. I don't care what clothes people are wearing. I don't care what color they are. I don't care what color their hair is. I don't care if their clothes are dirty or clean. I don't care what race they are or what they weigh. It matters nearly zero to me. The information I'm interested in is strictly utilitarian. So physical environment information, textual environment information, which isn't to say that there aren't times when other kinds of information might be useful, and is also not to say that I don't have an artist bent, because I do. I actually am a creator. I am an artist. I am a musician. I am a writer. But for whatever reason, the social aspect just doesn't impact me. Whereas with other people, it really does. So I don't have a good answer for that question. But I think the solution is to somehow provide a relatively user scalable, a way for the user to scale the information they want and need according to who they are, where they are, and what they're doing.
Alrighty then. So Will, maybe you could talk a little bit about your perspective on how Be My Eyes decides what to describe.
Yeah, it's interesting. And to double tap on your example, I kind of tend to agree with Daniel as a blind person, but we help thousands of people every day, every week, check their outfit and walk out the door with confidence in the morning. That's something that some folks really like to have, is the knowledge that the shirt matches the tie, or certain things that right now we're solving entirely with human vision, and the blind user has to state with language the task in order to get it solved by the volunteer. So in that respect, again, an entirely human solution, and targeting a task with language is 100% the most efficient way to do that. The question is, how can we create a model that learns after one or two or three tries, that I am usually asking about whether a tie matches a shirt, or I'm usually asking about the color of my shoes. And I think it goes back to what Andrew's saying about, we're going to have models that learn on the device, and that don't farm your data out to some algorithm somewhere, but know how to do this on device, and figure out your preferences. I think that's entirely attainable, but it all comes back to having a really good international, socioeconomically inclusive, multilingual data set, and I think we're working toward that, but that's to me, that's the way you go about creating those really good models.
So if I hear you right, and sort of combine that together with what Daniel was suggesting, I think what you're suggesting is something that's deeply personalized models that are associated with what a given individual is really wanting for the context that may vary quite a bit. Is that accurate?
Yeah. We have thousands and thousands of users, and they all use Be My Eyes differently. They all have different priorities. It's never the exact same task from user to user, but but each user has their patterns, right? Each user has the things that they care about. So understanding this sort of fundamental truth that there are as many different types of blind people in the world as there are different types of people in the world is really, really important. And that blind people are just as diverse and varied and complex and busy and nuanced and adventurous and complicated as every other human with 20/20 eyesight.
Well said. So Andrew, I mean, from your perspectives, do you have any observations about like what you include in visual descriptions, or what you strive to include or want to?
Yeah, I guess there's a couple ways I can parse that. I think Will and Daniel brought a really good perspective on this topic. Maybe I'll start first. We talked about maybe a future technology that could bring kind of the information you need when you need it, but we're not there. So one principle that I've kind of observed that's useful when maybe designing an app to be useful for people today is empower the user to ask for what they want. So make it kind of very easy for a user to basically get, say, the information that they want that's relevant, rather than trying to kind of guess it. In the future, we may kind of be able to co-adapt and predict what people want, but at this point, the simplest thing is just let the users, or at least make it easy to kind of gracefully fail to, and then let the user specify if something's wrong. Now, in terms of specific signals, obviously things like OCR, which was mentioned earlier, I mean, that's a very strong model now, very much a commodity thing, very useful. AI does a good job at recognizing objects, although, There's long tails on objects, so when we talk about these types of open world problems, maybe there's many common objects, but, there's kind of an infinite variety of objects in the world. And then, there's various types of maybe human sensing type of tasks. Like, I would think being able to share kind of affect, the emotions of someone else. Although maybe that could also be sensed through kind of language, how people are speaking. But these are some broad signals that could be useful, and figuring out which are kind of the useful ones at the useful time. Long-term algorithms can potentially solve that. Short-term, empower the users to be able to ask.
Excellent. So we've already heard a little bit about this from Will just a moment ago, but I think this is really core to the focus of the VizWiz workshop, which has to do with data. And in the modern world of AI, data is truly the unobtainium ultimate valued thing for making progress. And so I want to talk a little bit about the issues that are really critical for improving vision assistant technology, which is access to large data sets from people with vision impairments that sort of support evaluation and training of computer vision tools. And so I'd like to start with you, Andrew, and I'm wondering if you could discuss your expectations about how these data sets can be built responsibly. And also, if you have any experiences in building these kinds of data sets, what do you think we need for them? And, just in general, any thoughts about data?
Yeah, this is this is the question, really, because, AI is all about being driven by the data. So one distinction that I do like to make is the difference between training data and, say, test data or evaluation data. Because the test data and the evaluation data, that's kind of an opportunity to set a North Star. You can kind of embed the values you care about, inclusivity, diversity. You can try to, measure how models might do in different environments. And then you can try to either mirror your kind of test data with training data, or try to figure out how to, say, use semi-supervised, unsupervised, self-supervised methods to kind of bootstrap. Because, there is kind of a theme going forward on how do we use less data to train models strong. And that's kind of maybe self-supervised paradigms. So that's kind of how we might point, say, a North Star for a community or a product. In terms of kind of engaging with academia, folks definitely like standardized data sets that they can kind of use the word hill climb, show improvement of their algorithms and their techniques. And again, these challenges like VizWiz, this is a great way to raise kind of awareness that this is an important task. There's a scoreboard that people can now publish papers and say, I've improved the scoreboard, and they can feel like they're making progress on a task because this has been carefully curated to say, if you do a good job solving this task, it's going to actually help people in the real world. And, I really like that. Maybe to give maybe a slightly different context as well is, we've found things like the ImageNet challenge to be very useful to have progress over time. That's kind of like the standard lab experiment, I guess. And, that's really catalyzed the community. We've also run some challenges around kind of low power, and that's been really helpful to get kind of a community together around that topic and making progress. And I guess maybe that's some thoughts on that area, but definitely super important. North Star, community driven, those are the themes basically.
Daniel, any thoughts on data set building?
I don't really have thoughts about the way data are collected or the kind of data that are needed to make effective decisions, other than that data do need to be collected. It's hard to make assumptions. And I think we need data from blind users or blind consumers. I also think we need data from people who are blind, but by virtue of their profession or expertise or just maybe experience, can offer some, I'll just call them educated guesses. So I won't speak for other blind people, but I have worked with literally thousands of blind people in almost every imaginable context, almost every imaginable environment. And so I feel like I could propose, for example, if someone asked me what are the most pertinent issues that blind people face when navigating their environment, with a question mark, I feel like I can put that out there. And I think we need blind people to put that out there. I think we need to codify what those issues are, because the data have largely been quite site dominated, if you will, due to a long held site dominance in fields of instructing blind people. And I think that we need to turn that over to blind people.
Oh, super interesting. So you're also suggesting, at least from a point of view of data and the kinds of data that we need to acquire, et cetera, that also should be perhaps driven by blind people, or at least the inquiries that they're going to be pushing. Is that accurate?
Yeah.
Super interesting. Will.
Yeah, well, I mean, Daniel's, you can't say underscore enough what Daniel's point is, which is that if you're not integrating blind testers and designers into your development process, you're doing something wrong. You're missing out on a lot of really valuable insight and potential innovation. So that's huge. And I think when it comes to actually procuring a good data set and ensuring you're doing everything correctly, and you have to understand that there's just a tremendous amount of personal data and sensitive data that goes into visual interpretation with people. So slicing it between social, symbolic, physical, it's just the tip of the iceberg. I mean, and people are sharing, people are encountering barriers with all sorts of sensitive things, such as credit cards and pregnancy tests and COVID tests. And I mean, this is so you have to take that part of ethically and anonymously treating the data really, really seriously. And then there's other things to consider, like, well, how do we filter out commercial data? In so many cases where people need visual interpretation, there's a brand behind it on the other side of the camera who is designing a barrier. So it's one thing to solve the barrier for the blind individual, but then there's another task of making sure that data gets somehow back to the brand so that they can fix the issue and at its source, rather than simply solving it with on device with a sort of a Band-Aid interpreter service. So I mean, it's a deep topic, and it's something we're thinking about a lot at Be My Eyes. And having been European, kind of core to our company, we've always, since day one, been highly attuned to GDPR and really the highest standards of privacy. And that's the mindset that we go into everything with, whether it's research and development or testing or anything. So yeah, it's a big topic.
It really is. Thank you. I almost want to dig a little bit deeper on this, just because of all the questions around both the ethics of withholding information, but also like the ethics of like sharing. So you've got both. And I think there are really deep questions about like, well, if we withhold all of the personal information that we have that we may need to withhold for lots of good privacy reasons, we're also limiting the kinds of models we can build that are actually important, that are deeply personal to people. And I think it's a super interesting question. But we're running out of time, so I want to make sure that we hit our final question here. And I think this one is really important because it's fundamentally about this much bigger village that we're building in this, and the fact that the problems that we're trying to solve here are really multidisciplinary problems. They really can't be solved by just technologists or just the blind community or just a random company. So for a final question, I want to start with Daniel, and I want to say, can you share about what extent you've had conversations with or collaborate with researchers, industry developers, blind technology advocates to advance products and services that can advance visual assistance products and services? And in particular, what do you find works well versus what doesn't work well in these kinds of collaborations or conversations? So we'll start with Daniel.
Well, loads. So I I became an orientation and mobility specialist about 22 years ago. No, longer, 25 years ago. And I felt, I mean, my background is as a developmental psychologist. So I have a master's in developmental psychology as well as a master's in special education. I drew probably more on my psychology than my education training, and discovered very quickly that the field of orientation and mobility really doesn't have the answers. At least it doesn't have most of the answers. And if you want an answer to navigation and environmental interaction, to freedom of movement into and through the environment, it needs to be an interdisciplinary, cross-disciplinary effort or approach or network or whatever. So the mobility field is very siloed in its own thing. And I then went out and have consulted with psychologists, neurologists, auditory experts, occupational science people, and people who look at ergonomics and parapersonal space and things like that. There's a whole science around, for example, what makes a device become a natural extension of a person's perceptual system, whether it's a golf club or a ski pole or running shoes or whatever. But somehow this very same science hasn't been applied to the white cane, at least not broadly speaking. So I don't want to dominate the response here, but I think that's basically it. I think that an intersection of tangential disciplines is absolutely needed to approach solutions.
Fantastic, thanks. How about you, Will?
I think from Be My Eyes perspective, we mostly have worked with industry up to this point. We have great partnerships with Google and Microsoft and many other companies, Spotify, other technology companies. But that's largely been to sort of manually help them gain insight into how their products are working for users. And that mostly is a relationship between the companies and the users. We're more of a switchboard in that respect for connecting the community with those companies. I think where we can expand is on the academic front. I think we're actively trying to figure out how we can leverage the activity in our community and the passion that all of our users have for accessibility to get researchers involved and get researchers good data on what the blind community's needs and wants are. we're working on that. We've kind of just started on that, but we've already seen some really promising potential there. And I'm also really open to the idea that, empowered to do so, our community of users would actively participate in this process and contribute a little bit, micro amounts of time and energy when they have it to sort of help us guide this sort of heat map, as it were, of what are the tasks that need to be solved for the blind community. So I'm optimistic that there's a lot of great research and development to be done from within our community in the years to come. And I would really invite anyone who's watching to reach out to us at Be My Eyes and start a conversation, because I think we're very, very open to that and very committed to the cause that we've been talking about today.
Thanks so much. We'll close with Andrew. What do you think?
Yeah, maybe a couple quick details. In terms of my direct collaboration with this community, I've worked some with the folks at Project Guideline, as well as the folks at our Lookout app. But that's been more about like an enabler with technology, and they would more directly, the engineers there would work on the problems, and they would have their own kind of relationships and interactions with the community. When I think about how to bring communities together, there's kind of maybe three broad communities we're maybe talking about here. We're talking about specifically the kind of blind community. We can call maybe users, if you like. Then we have the research community. These are people who are kind of publishing and trying to move things forward. And then you have kind of maybe the tech companies. And there's overlap in all three of these groups. But all three really kind of need to kind of come together, because the research community can kind of solve the problem over time. And then the kind of tech companies, whether startup or large tech companies, can then put the technology out there based on the research. But then how do we kind of drive that whole pipeline? Because again, it is a bit of a cycle. Pipeline can be driven by creating the canonical tasks and measurements of success by the community and get that embedded within kind of academia. And then really enable kind of, the best and brightest, hopefully, to go and solve the problems. You can also think about potentially driving standards. Like, here are examples of problems we want to solve and create kind of an industry standard around this, where then, the technology can say, this app is this good at solving this standard task. That's maybe another way to harness things. And that's one way that multiple tech companies can kind of come together with the community and kind of agree upon what are the standards of success.
That's fantastic. We are at time, unfortunately, because I would love to continue this conversation for a lot longer, technology permitting. But I want to just, first off, I just want to say this has been an amazing conversation. And I really enjoyed hearing all of your perspectives on this. Thank you so much for sharing your valuable time for today's conversation.
Thanks so much for having us.
Thank you.
Next panel will begin shortly. Next panel will begin shortly. next panel will begin shortly. The show will begin in 1 minute. The show will begin in 30 seconds. The show is beginning.
Interdisciplinary Panel 3. A product developer, blind technology advocate, and computer vision researcher discuss the future for visual interpretation technologies. Moderator, Donna Gurari, assistant professor, University of Colorado Boulder. Speaker, Saqib Sheikh, software engineering manager, Microsoft. Speaker, Robin Christopherson, head of digital inclusion, AbilityNet. Speaker, Marcus Rohrbach, FAIR research scientist, Meta AI.
Hello, and welcome to this panel discussion of the VizWiz workshop. My name is Donna Gurari, and I am an assistant professor and the lead of the Image and Video Computing Research Group at the University of Colorado Boulder. I am so excited to have with us today 3 panelists who are going to bring a range of perspectives around the development of computer vision technologies to meet the interests and needs of people with vision impairments. First, we have Robin Christopherson to share the perspectives of people with vision impairments based on his personal experience as well as his professional role at AbilityNet as the head of digital inclusion. We also have Saqib Sheikh to discuss the development of industry products that use computer vision to assist people with vision impairments. Saqib is an engineer manager at Microsoft, where he founded the mobile phone application called Seeing AI, which uses AI to describe users' visual surroundings, such as recognizing objects, currency, and text. And finally, we have Marcus Rohrbach to speak with us about the cutting edge of computer vision research. Marcus is a research scientist at Meta AI Research and is most well known for his work at the intersection of computer vision and natural language processing. Welcome all. It is a true pleasure to have each of you with us. And with introductions completed, I am excited to now dive into our panel discussion. So to begin our conversation today, could you please share about what has surprised you the most about progress that has taken place over the past 10 to 20 years around technologies that provide visual assistance to real-world users? Saqib, could you kick off this conversation?
Well, yeah, I think when you think over such a long time, like 10 or 20 years, it's funny to think how much has stayed the same and how much has come so far on. So it was maybe 2004, the first time I saw a video call. And for many blind people, that remains the way of getting remote sighted help, is just making a remote video call. But of course, it's so much more available today. And I think it was about 10 years ago, the first time I saw both remote human assistance via an app, as well as the first glimpse of AI that could sort of describe what's in an image, though 10 years ago was so basic. So it's interesting that
on those time horizons, they are the basics of what we have today. But my goodness, things have really, really come a long way. Automated image descriptions, yes, they leave a lot to be desired in terms of context, but they really are getting quite good to give an idea of what's in an image. And when it comes to remote human assistance, with crowdsourcing solutions like Be My Eyes, suddenly, in addition to make that video call to your loved one, you've got this army of volunteers around the world who you can call on. So, yeah, technology has really built on those fundamentals, those foundations, but come such a long way.
Great. Robin, would you mind sharing your thoughts?
Yeah, just following on from what Sakib was saying, I mean, he didn't mention the Disability Answer Desk within Be My Eyes, the brilliant go-to way of getting access to Microsoft's accessibility services, with a remote expert pair of eyes, or indeed, joining a team viewer session or, quick assist session on your desktop and that sort of thing. So all of these technologies, as Sakib was saying, have been around for a while. But certainly in the last sort of 10 years or so, I think the real power is that they're now with us all the time in the form of a smartphone. Scanners, desktop scanners and, cameras and all these other kind of object recognition have been around for a lot longer, like Sakib was saying. But the power of smartphones with us all the time, plus they have all these different sensors. They have the camera within them, but they also have extra sensors. And when your own sensors don't work, you want as many sensors going for you as possible. So GPS, accelerometer, compass, I use all of those in my phone all the time as a blind person, along with the camera and LiDAR and things like that. And, just take the two Microsoft apps, my go-to apps for outdoor navigation and for kind of indoor object recognition or outdoor, Seeing AI and Soundscape. They use all of those sensors as well. So I think, as Sakib was saying, it's the coming together of all of these disparate, longer standing technologies, but in a format that is so much more democratizing. It's with you all the time. It leverages all of those in really clever ways. It brings them all together, plus the crowdsourcing that Sakib was talking about as well. So we're living in really exciting times. And as Sakib was saying, there's still quite a way to go when it comes to replacing humans in the AI side of things. But I know that his team are working hard on that as well. So yeah, we're living in exciting times.
Thank you, Robin. And Marcus, would you mind sharing your thoughts?
Yeah, I'm not sure I can add too much to it. I think that was a great summary from Robin and Sakib. I think I still feel like that there was there's an amazing AI revolution over the last 10 to 20 years. So in artificial intelligence and what we can do with machine learning. And I feel like we are still there's been, of course, significant progress, but I think the visual assistance to users is still I feel like the field is further than how far we are with the ability to assist users. And I might not know all the applications as well as Robin and Sakib, but I feel like there's probably we're going to, in the next maybe 5 years or so, I feel like there's still going to be a significant advancement just by the advancement the research field has made, which is not yet maybe in applications and especially not in assisting real users.
Great, Marcus. That is a great segue into my next question, which is, what do you see as the current limiting factor or barriers in developing better visual interpretation technologies? And so, Marcus, would you mind kicking off that conversation?
I think on the one hand, I think there's still while we have this at least in the research community and most of my expertise lies, there's a lot of data, of general data out there, but the amount of data which is there to train multimodal assistive technologies is somewhat limited still. So I think, of course, the VizWiz data set is a central way to test things, but it's still from the size and the breadth is still not as far as we would need to build really strong applications and study really hard tasks.
Thank you. Sakib, would you share your thoughts?
Yeah, as Marcus was saying, data is a huge one. Sometimes we call this like the data desert. There just isn't enough data relevant or applicable to people with disabilities. And that sort of comes to the bigger point that while we're working on these huge scale models which try to generalize to everything, we've made huge strides there. But I also think on top of the data sets to support those huge models, we'd also need some way of personalizing for the individual, and acknowledging that every context, and that context could be the kind of photo, like is it a social media post versus real world, etc., etc., but also the person's environment, location, interests, all the way through to what's of interest to this person right now. So I think we're going to see advances on both sides. The large-scale machine learning, computer vision, which will try and create these large-scale general models. And for that, we need the diverse data set, which is representative of people with disabilities. But then I'm excited about personalizing that on the other side to be context-aware and human-aware of the individual.
Thank you. And Robin, would you share your thoughts about what are the current limiting factors in developing better visual assistance technologies?
Yeah, I'll start by echoing Marcus and Sakib because, data is king, and it's really, really important that as much relevant data sets are pulled together to feed the neural engines and the AI. Brilliant announcement by Apple recently that they are including door detection in their next OS, so that that last sort of 5 yards problem that a brilliant app like Soundscape can get you to within spitting distance of the door. That's not a good metaphor, is it? Within not quite touching distance of the door, and then you have trouble finding the door. So often I'm feeling windows in a shop. Does this feel like a door? If I just keep going a little bit longer, you finally get to the door or somebody takes pity on you. So they've obviously put a lot of effort into the data sets around, capturing what thousands of different doors look like probably. And not only that, but door handles. They can recognize whether, the kind of door handle that they're seeing on this side of the door, does that imply it's a pull or a push or a turn? And they're also grabbing the text from, are there any signs on the door about push? Are there opening times or names of the store or whatever it might be next to the door as well? So all of that is built into the magnifier app in iOS 16. So that's really, really good. And they must have had to put a lot of time and effort into doing that. So that's absolutely brilliant. I think, though, the main barrier is just time and resources, because there's so much potential here. I was talking to Sakib offline a couple of weeks ago, and he's got a big wish list for seeing AI. And it's just a question of time, manpower, and, making sure that those can be brought to the user as well. So, the teams that work on these probably are 10 times as big as they were 10 years ago, but still, that I think that the sky's the limit, really. And it's just about prioritizing it within these organizations that are doing good work.
Awesome. So that's actually a great segue into my next question, which is, could you describe how you envision technology will work in 10 years for interpreting visual information for real-world users? And this can be anything from, what will the skills be that the technology has, to what is the form factor and how it will be delivered. And so, Robin, would you mind sharing your thoughts first?
Yeah, I think, these guys, I'm sure, have got a lot more to say about interpretation of images in a sensible way. So not only can you, point your camera in camera mode and take a snap, or in video mode in real time, and capture the different objects that are in there and their trajectories and telemetry, using LiDAR, for example. But how do you then interpret that in really meaningful ways, and what are the key bits of information that you need? And that's about context, and I'm sure Sakib will want to talk about that. But these days we have AR type glasses for people with low vision that can put a sort of a white bold line around edges with using edge detection and around door frames and stuff like that to help them better interpret their environment for safety and navigation reasons. And I could imagine that that would get more and more sophisticated, so that whatever your particular preferences were for colors, for high contrast, for, you know, really highlighting different objects, that could be done really well in real time with something that doesn't feel like you've got a great big bucket on your head or kind of big gaming rig or something. So much more kind of discreet everyday wear. And maybe if you've only got a little bit of vision left at the, you know, left-hand side peripheral vision or something, maybe that could be where the sort of central vision bit could be shifted to, so that you get a lot more of an idea about, you know, your useful bit of vision is being used for the thing that's directly in front of you, that sort of thing. But yeah, I could definitely see AR or VR being used to give people the exact visual interpretation of the world that they want. Maybe if it's a really busy background behind the thing that you want to look at, it would just green screen that background out, you know, a bit like blur or portrait mode or whatever, to make it much simpler for them to concentrate on the things that they need to see. So yeah, I think the sky's the limit, as I say. It's just a question of the imagination and resources of the different teams that are kind of looking into this today.
Well, I'd be excited to take advantage of that kind of a vision if it came to be. Marcus, would you mind sharing your thoughts about where we're going to see technology go in the future?
Yeah, so I think one exciting avenue is that sort of, I think visual interpretation becomes maybe much more useful for or important also for lots of applications which don't center out low vision users and visually impaired users in general, but also for the general population that might spring much more investment in this area. And I mean, we've been seeing several companies also investing in classes and augmented reality, and that this being such a big market, if it's available for everyone, there will be much more investment, and hopefully this will allow for technology to evolve much more, that having classes which can assist you, for example, or other wearable devices can be much more powerful and sort of be sort of more continuously assisting everyone with different abilities, with different disabilities, to sort of have sort of a natural interaction with artificial intelligence and, of course, also other people.
Thank you. And Sakeb, would you mind kicking off this question?
Well, yeah, big picture. Really, if you imagine that there are a billion people with some form of disability, but then actually every human is different. So I really imagine that the future of this technology is about becoming more aware of the human. So can we build systems that observe the world around us via sensors like the camera or LiDAR or anything else, or maybe network sources, and build up that model? And we've started to do this with LiDAR and augmented reality with the Seeing AI World channel, where you build up an understanding of what's around you. But then you also build up an understanding of the human you're serving. And every human is different, and then you convey what they want to know, reactively or proactively at the right time. And in this way, I want to be able to walk into a party and to be able to know where my friends are. I want to be able to join the end of a line. I want to be able to, do so many things, which are currently challenging. But to remember that every human has their own challenges, but also has their own coping mechanisms. And for then AI to fill in all the little gaps, I kind of really, for me, I sometimes imagine it as a little agent sitting on my shoulder, whispering in my ear. I really want that advocate for me. And I really think we can get there with advances in AI, wearables, and HCI.
Thank you. So I think that's a really interesting point about thinking about, how do you personalize? But more generally, how do you go about deciding what information should even get included when you try to interpret visual information? And so I would love for us just to talk a little bit about, what do you think should be the process for deciding what information to include in a visual description? Because at some point, the AI developers are going to have to make that decision. And so, Sakeb, would you mind starting this conversation?
Ideally, you would put that in the user's control. Because if you're going to just generate one sentence, one caption per image, then it needs to be the right one. But if you could perhaps start with a very verbose, rich caption, but then allow people to zoom into different things, like having either a visual region of interest, but also perhaps a topic region of, a topic of interest, I think that would be really powerful, so that you can say, hey, this is a person standing here, but you could say, actually, you know what? I'm really interested about what's behind the person. The person just happens to have come into the photo. And suddenly you'll get a whole different description. So I think that ability to zoom in and out, include and exclude different objects, regions, will be very cool.
Great. Robin, can you share your thoughts about how we should go about deciding what information should be included within these visual descriptions?
Yeah, I mean, it is a difficult one. And like Sakib was saying, it's really down to personal preference, also time constraints. I think in Microsoft meetings, often they say give a brief description of themselves. And, that's kind of time constraint. So context, as Sakib was saying about, being able to kind of interrogate other aspects of the picture on demand, rather than giving you a great big long spiel about every kind of aspect of the picture, is another kind of example of that. I think how Seeing AI does it is really good for the kind of succinct summary. So, 38-year-old man with brown hair and blue shirt, wearing glasses and looking happy, that sort of thing. That's kind of a good, succinct description. But then there is this argument that says, there are sensitive areas around body shape, for example, race, all this kind of thing. Have they got a facial disfigurement, that sort of thing, which other people who can see or have access to. So there is this argument that says, well, just because blind people don't happen to be able to see that person, don't they still have a right to have access to that information? So, at lower layers of information that you could ask for, maybe the fuller description would actually include body shape and, other striking features, because we kind of have a right to know. So this goes on to the kind of whole ethical thing. And there's certainly a lot of ethics around AI and, the integrity of data sets and that sort of thing. And they certainly aren't well representative of minority groups. So yeah, there's kind of a whole discussion around that. But I just totally agree with Sakib that I think you need to be able to interrogate at different levels. And I think we do have a right to know.
Thank you. And Marcus, could you talk about what it's like from the computer vision perspective of deciding what information to include in a visual description?
Yeah, I mean, I think it's a very hard problem in general to decide on this, and actually even like have models learn these different variants and make them personalized, especially because there's sort of again, sort of going back to what you said earlier, there's sort of very limited data which allows to learn this sort of personalized aspects and learning how to personalize the different different captions or different information you want to provide to a user. So if you would have this ability to sort of that the model actually can guess, especially if the model is over time is the same user, ideally it can guess what the user wants in a certain situation. And then only the user can maybe fine tune sort of the additional information they want, if there is a question or with maybe different, maybe with pointing, there could be all kinds of forms of interaction beyond language. So maybe language is the most natural one. And of course, it is actually very challenging to talk about body parts and race and gender, just because that's very difficult for AI to handle, to be not biased. And it's also a societal question. So I think there has to be also just a discussion in the society, what's the right thing to do there. I think it shouldn't be the AI alone deciding that, or developers deciding that. Probably like a society thing, and maybe that there's also a localized society thing. So maybe in some societies people are more open to that, in other societies people are less open to certain things.
Thank you. So slightly switching gears, I would like to now talk about something we've already addressed in this discussion, which is the issue of how do you go about creating these large-scale data sets that typically we need to develop visual assistance technologies. And so we know that these kinds of data sets are they're the foundation for us to evaluate computer vision models, but also often to even train models. And so I was hoping to hear from each of you about your expectations about how such data sets can be built responsibly and any experience that you have in building such data sets. And so maybe, Marcus, would you mind starting and sharing some of your perspectives as someone who develops the cutting edge of computer vision technologies?
Yeah, I think it's a difficult question. I mean, all the points you mentioned are hard. I think one thing we looked at is sort of specific tasks which might be technology-wise not mature yet, and sort of focus down on them. Sort of one example we focused on the sort of reading scene text in the image. So we sort of focused on a data set and sort of let's focus on a subset, which is maybe on the one hand a bit disappointing, but on the other hand allows to collect a reasonable sized data set without putting like millions or billions of data points, which is probably in many cases infeasible. I don't have a good answer about sort of the what is the best way to get diversity. I mean, ideally, you get all these diverse sources of data with respect to image, with respect to users. But it's easier said than actually done, because typically lots of data is not available. Lots of users are not maybe don't want to share the information, or are basically not maybe connected to phones or internet as well as other parts of the society. That's really difficult to actually do this like really fair. And I think in part there will be always some imbalance in the data. So the other side is, I think there has to be some algorithmic side which takes into account that we won't have completely balanced data. That won't just happen. There will be always bias. There will be always sort of not capturing everything the same way. That's just how the world is. So even if we would capture the entire world, I think it would still not be fair, because there's just smaller populations and larger populations. And we have to just have AI or whatever technology we're using, be aware of that and design accordingly, which is of course very hard, and I think it's sort of a part of active research.
Thank you. Saqib, would you share your thoughts?
Sure. So I think of this again as before on two fronts, the big data and the little data. So we're working with our responsible AI team at Microsoft to seeing AI processes millions of images every year, mostly taken by people who are blind, or certainly, requested by people who are blind. And so we have a diverse variety of photos coming through the system. We don't keep any of them today for privacy reasons, because we don't know, the people submitting the photos don't know what's in them at the point of submission, etc. So we're working with a responsible AI team to think, what is the best way to allow users to opt in with meaningful consent? And what does that mean down the road if something were to change, or they change their mind, or all these interesting questions around privacy or PII. And then that's just for gathering a data set. But then, of course, you need to be able to process that and either get it labeled or use supervised or semi-supervised techniques where you don't need so much labeling. So that all of that is actively being investigated, so that, these millions of photos, could we use them to further improve the state of the art for people who are blind. So that's on the big data. But then, as I said before, at the end of the day, we're all humans, we're all individuals. Someone with 3 dogs said, I'd love to know in which photos was which dog. And I'm like, at that point, really, that comes down to the user experience and allowing someone who's blind to be doing the teaching, not only the consuming of the model, but the creation of the model. So we're also working with the researchers on that. So how do you get someone who can't see an object to teach an object, such that that gets included in the descriptions because it's something they're interested in?
Thank you. And Robin, can you share your thoughts about how to go about building data sets responsibly?
Yeah. First of all, I want to very briefly go back to what Marcus was saying a while ago about ideally the model or the machine learning would learn how much information you want and kind of curate the experience to you. And I think that's a brilliant idea. In an ideal world, it would kind of learn your preferences and that sort of thing. I do feel like we've got a long way to go from where we are today. If, for example, the stock responses within the Apple Watch iMessages app, so someone sends you a message and then you can flick down to just below the kind of edit box to the stock replies, and there are things like be right back, or I can't think of them. They're just the worst responses ever. And I've never, ever tapped on one. And, it doesn't learn at all from the fact that I might bring up the keyboard and find the emoji and give them a thumbs up or something like that. They just haven't changed at all. Or if they have, then they're all so bad, I haven't kind of noticed that they have. So, yeah, I think there's a lot of scope for a personalized experience in the level of information, the sort of data you get served up by AI. But it feels like we're in the early stages there, or at least that those particular implementations aren't particularly good. But going back to the question in hand, I agree with the guys. It's all about the data set. And I was working with City University in London for their Orbit project, nothing to do with the Braille display, which they created an app with some really good instructions about getting blind and visually impaired people to take pictures of the everyday products, not just VI related products like their white cane or their dog's harness or Braille display or something, but everyday stuff that they need to find, like their keys and whatever they need to find, their shoes, but taken from the perspective of somebody who's who hasn't got any vision, so that the lighting might not be great. Maybe they're taking photographs of these objects, if they've managed to find them, in the locations where they potentially will have left them will leave them in future. So the context helps with the model and that sort of thing. And that comes back to what Sakib was saying about personalization, the small data, which will make it very specific to that individual. So there's the larger data set about making sure that the model includes more information about the sort of objects that people with a vision impairment need to find or kind of identify, but also taken by them, in the way that maybe the lighting isn't as good as it would be in the other data sets that have been, curated or kind of compiled from more conventional means. But then the small data would be, these are my very specific keys, or this is my very specific favorite mug or something. And I'd love there to be a training channel in seeing AI. I'm sure that's the kind of thing that Sakib and his team are talking about, or whatever it might be, whatever the vehicle would be to kind of help with augment that data set, because this Orbit project would be hundreds of users and people involved, whereas, as Sakib was saying, for seeing AI, it's just on another scale altogether.
Thank you. And so now coming to our final question, the premise of these kinds of conversations we're trying to put together is that we believe it really takes a collaboration between researchers, industry developers, and blind technology advocates to advance products and services that are available for visual interpretation purposes. And so for our final question, what I'd love to hear from each of you is your thoughts on what do you find works well versus does not work well in collaborations or conversations you've had, and also just sharing a little bit about any kind of experiences you've had collaborating with people of other minds, whether it's researchers, industry developers, or blind technology advocates. And so I would love for Sakib to start us off with this conversation.
Yeah, I think the partnerships really are key. For me, that starts, internally. Our whole project, I think of as a conversation between the blindness community and the researchers at Microsoft and in academia. So, we're looking at what are the daily challenges that we hear about from the people we talk to in the community, whether that be at conferences when conferences were a thing, or by email, or the feedback channels, and so forth, blogs, podcasts, all the way through to user research studies. And on the other side, then talking to the scientists at Microsoft and Microsoft Research and our computer vision teams and saying, what's in your bag of tricks that we could use to improve people's lives? And then Microsoft Research also does those academic partnerships. For example, Robin mentioned the Orbit project with University of London. And then also, Dana, you would know the UT Austin collaboration we did on image captioning, and there's many more besides that.
Thank you. Marcus, would you share your thoughts?
Yeah, I think my focus so far has been mainly on the research side, but I've been talking to visual impaired users, both within in the company and outside, and also with sort of the accessibility team, what they are thinking of on what's sort of their roadmap, where they see issues. I think that's sort of very important to sort of get the context and understand sort of some of the sort of context out there. I think there's also room sometimes for sort of thinking of things which maybe users might not be thinking of at the current stage. There might be some aspects which I always bring this example of the mobile phone. I mean, I didn't need a mobile phone or like a smartphone when it didn't exist. So I think I think there's sometimes maybe some creative. I would have probably said, I mean, personally, I would not need a smartphone, but now I'm using it all day for all the different tasks. So I think there's sort of sometimes maybe some creativity which goes sort of like if you look like 10 years in the future, which maybe users might not even not even think of right now. So I think there's sort of these two ways if we think about sort of products and things which sort of in the near future, I think it's very valuable. But then sort of maybe for some technology to develop, we have to maybe go beyond sort of what individual users think.
Thank you. And Robin, would you finish us off with your thoughts?
Yeah, I mean, I'm ashamed to say that, myself and AbilityNet more generally aren't kind of actively involved in setting the agenda of the future of products and AI and that sort of thing. We endeavor to know about what's out there and what's potentially around the corner, but not to kind of set the agenda. So yeah, we're kind of kept busy because we're a pan-disability organization. So, knowing about what's out there, how the different technologies work together, if you've got more than one disability, for example, is kind of a full-time effort for us. Having said that, though, when you've got a lot of connections in different organizations, as we have, I definitely take the opportunity to bend Sakib's ear, for example, or to talk to Christopher Patno at Google or whoever it might be, across different organizations to kind of pick their brains and kind of enthusiastically talk about where things might be going. So yeah, I think the more enthusiasts we have out there, the more, people can start to get really excited about the future. And hopefully the more those efforts will be prioritized with budget resources, senior buy-in, to make sure that, organizations like Microsoft and others really do, carry on doing great things going forward.
Thank you. Well, we are now at the end of our panel, so I just want to thank each of you for making the time to share your thoughts. This has been a truly fantastic conversation.
Thank you for watching. The VizWiz Grand Challenge Workshop will return in 2023.